So everyone is like, it's going to destroy your battery. And it's like, actually, it doesn't. And oh my God, like I built a UI with 9 million panes and 15 widgets per square millimeter. And like, it costs me 0.3 milliseconds. And like, it's actually like insanely fast. It's like, I feel very passionately that like most people making a game don't know what the game's going to be. But in order to discover what the game is, you need to be able to iterate really fast. That is the number one MSB, nothing else matters. Iteration count is the only number that matters.
Welcome everyone to another live stream debate. I'm not sure what's going to be debate, but I always market this as debates and then nobody wants to come to them. But anyway, debates about game architecture and also programming ideas in general. With us we have Alex Evans and Anton Mikhailov, who know each other from working together at Media Molecule, one of the beloved studios from UK. So let's start with a round of introduction for everybody who is not familiar with those people. Alex, can you say a little bit about yourself?
Yeah, okay, so hello, thank you very much for having me on. I am a demo scener originally, so I learned to program to make music, and then I made demos as statics. So if anyone is old enough to remember the demo scene, I made some paper, demos called Paper and 303 and things like that. From there I got a job at Bullfrog, which was a beloved UK studio, making tea mostly. I worked on Dungeon Keeper very briefly in my summer holiday. From there I went to Lionhead, where I worked on Black&White as the graphics engine programmer, or one of the graphics engine programmers. And while I was at Lionhead, I met my future co-founders of Media Molecule, and we worked together on a number of projects, including a sort of hobby project that Mark Healy had, which was a game called Ragdoll Kung Fu, which ended up being the first third-party title on Steam, because I happened to know the Valve guys quite well back in the day, and they were like, oh, we're working on this distribution platform called Steam, but we haven't got any games to put on it yet, apart from our own. Would you mind asking if he would put his like crazy indie game on it? And this was before indie games were a thing. From there we formed Media Molecule. We worked on Little Big Planet and Tearaway and then Dreams. Media Molecule continues, but I have since gone off into the world of research, where I worked at Nvidia, and I worked on something called Instant NGP, which is well known for a nerf, which is like a 3D reconstruction algorithm. It was the first nerf that was quick and fast, and I have an obsession with fast turnaround time because I have a short attention span, and from there I've moved into the world of generative AI. But basically I think of myself as a graphics and audio programmer who's got lost, and I'm just meandering around the world at this point. So
Graphics and audio programmer that is lost. I think that's not an apt description of you, but okay, let's do it.
Yeah,
Anton, maybe a couple of words about yourself.
I'm a lost UI programmer.
Yeah. Well, actually, that's it. Anton, you should talk a bit more about. I know you did an amazing. If everyone on the stream hasn't seen the Anton Wookash episode, it's hilarious and very long, very funny. But I was going to say, like, you're underselling yourself there as well, in the sense that like the feel of using Dreams, which is the product that Anton and I both worked on, and it was a wonderful product at Media Molecule. It wasn't just us two, obviously, but the feel of how you sculpt and how you interact with the game was a product of a lot of people at the studio, but Anton was sort of shepherding it into code. So he was taking the ideas of the art director Kareem and the designers and the brilliant team, and trying to sort of shoehorn that into something that feels great to use. Now, if that's UI, then sure, you can call that UI, but it's actually quite interesting and rare and undervalued skill, because it's game feel. It's like, does this gunplay feel great in a shooter? It's like, does this jump height feel great in a platformer? But it's applied to editing tools and creation tools, and I don't think there's enough of it on the. I mean, obviously that's now your thing in Adobe, but there's not enough on the desktop platform, and on, you know, like if you think about different editors and things, the game feel of editors is not something that's often talked about, but should be.
Yeah, I tend to fall into that sort of stuff because I think I make stuff like I kind of really enjoyed making. I actually really like Dungeon Keeper because you're like building dungeons, but then later on I was like, oh, I'll make like levels and for games and whatever. And so because I think I have like first-hand experience with that, and then programming for me, it's just like well, how would I want to do it? And this is how I want to do it. And so I can kind of understand when the artists ask what they do. So that's what I end up doing. But yeah, like whenever I tell people at other companies, like, I'm a UI person, like, oh, like React. And I'm like, no, like C++. And they're like, what? Like Qt. I'm like, no, like OpenGL.
Yeah, exactly. Funny enough, I just started as a hobby on a little live coding environment for myself, just as an experiment. And it has a little editor in it, just so you can type code and see and hear the results. It's like Shader Toy, basically, sort of thing. But I started from OpenGL, and people were like, "Oh, which editor are you using?" Or like, "What is the editor? Is that a web view, overlaid?" And it's like, no, it's just OpenGL, and it's actually a full screen quad, and just go. But I was going to say, like, the through line of my career, retrospectively, is like tools, and I realize it dates back to Bullfrog. And one of the things I wanted to talk about on this, like, if people are interested, is like, once you build sandbox games, so Bullfrog was known for like Populous and Powermonger and these games which had a kind of sandbox feel. Like, you can think of it in modern terms like Minecraft and those sort of games. And once you have this open sandbox, the funniest thing is that the skills you need to make those sort of games work, so you're not going to have much pre-computation, you're going to have these open world emergent behaviors, you're going to need to handle dynamism way more than a scripted Golden Corridor kind of game. So it's a totally different set of like weightings. Like, if you're building a Golden Corridor game, that's not better or worse, but it's like you have a content pipeline and you have very specific things, and very like I remember Valve telling me that they actually figured out how many dollars they were spending per square foot, and they made sure that the dollars were spent on the bits that the user saw. But if you're building a sandbox game, you don't have the same kind of sense of where that's going to be. Anyway, so I was thrust into Bullfrog by and Syndicate. I played Syndicate with my friend, and I was like, I bet you can't get a job at Bullfrog. I'm like, right, okay, you're on. And I rang them up and said, can I have a job? And they said yes.
This was your interview?
Well,
come on.
Yeah, that was my. Well, so I was 15, and I was like, I'm studying games at school, and they were like, nah. And I was like, well, I do demo scene stuff. And they're like, oh, come and show us your disc. So I came in, just a summer. It wasn't a full job. It was like a summer job, and I showed them my demo stuff, and they were like, oh, you can come for the summer. But anyway, sorry. But so I stumbled into this world of sandbox games. And the editors I wanted to talk about Bullfrog were wild, because they were just the game. But it only works because they were sandbox games. This wouldn't work if they were building Unreal or doing or something. The editor was literally... So I remember they had a rock placement thing or an object placement thing in Magic Carpet, I think it was. And literally they would just spawn an object, and just there was a single integer variable, global variable, that was like the rock that is being held by the player, creator, whatever. And then they would just every frame set the rock to wherever the player was looking, like a foot. And then they were like, oh, let's just randomize the position and rotate it. So it would be like jittering around like this. And now you had randomization, and then every time you hit place, it would just drop that one and make a new one. And so they suddenly had randomized placement, procedural generative tools, the sort of things that you see now. It's like, oh, I can do this in Blender with a massive geometry, amazing stuff. I'm not dissing any of that stuff. But it was so hilarious that because they came from this mentality of everything is a sandbox, nothing is pre-computed, we can just fiddle around. And so that's where I come from, is that vibe of everything is an editor. There's no such thing as a game. Everything is a thing that you can mold and create in. And if you look at all the work I've ever done in my whole life, I feel like that's the common theme, right? It's like it's some sort of act of creation, but it's not philosophical, deeper in any way. It's just like something that you can use to do Lego with, or to do make stuff. And I just love the emergent properties of those kind of sandbox / editor things. I think Anton, if that's something that you can riff off, but
yeah, I mean that's kind of like the flavor on which we built the Dreams UI, because kind of by definition, it's almost like this. I think when you brought up Blender, like I had this sort of thing light up in my head, because like Blender node graph procedural, it's kind of like the retained mode of editing kind of vibe, whereas like this rock in middle of screen click is like the immediate mode of creation. Totally. It's sort of like those are the same light paths that show up in my head, because it's like one is optimizing for how can I make it as humanly possible to like riff with the human in the loop of the creation. So like every change gives the human an opportunity to change their course. So it's kind of like maximally jam
happy
oriented
machine.
Whereas like and like it was like somewhat well, I think Kareem intentionally wanted to guide the UI in that direction for Dreams. I wasn't intentionally guiding it because I didn't understand what I was doing, but later towards the end I was like maximizing for that, which actually has its own drawbacks. But like those tools maximize for that, whereas like the Blender version maximizes for something else. And I don't know what it is exactly, but it's very like you don't get to see the stuff until you see it. And I think that through line makes sense for your short attention span of like code iteration, because code iteration is the same way, like live reload versus the same dichotomy exists with like live reload and test.
I think we've stumbled into a full dichotomy, and it's my fault because I brought up Blender as a contrast. But I actually think that the geometry nodes and these kind of noodle graph flow-based things, the fundamental thing isn't the noodle graph. The fundamental thing is that I think they were optimizing, or people who build noodle graph things tend to be optimizing for a live feedback loop. So ironically, the goals there are some shared goals there of like fast iteration and, you know, quickly seeing your results and being able to experiment. But it's funny, they're like different flavors. Like there is a division here, and like there is a useful taxonomy like split between the rock and the flow graph. And I think it's also who you appeal to. Kareem was very into like not building cockpits, and I actually failed a little bit. So in Dreams there's some UI of like, we call them like tweak menus.
Yeah, we had big fights about that.
And I was the source of failure there. Like I was the Mr. Tweak menu, and tweak menu is like in some sense in the Anton school of thinking, rightly, is to tweak menu is a failure. Like you fail when you have to like fall down to a property. Like a tweak menu in Dreams is basically a right click, you know, property bar, or like an inspector on the side of Unity or anything like that. So if you haven't used Dreams, you can think of tweak menus as like the PS4 version of a property inspector. And in some sense, you do that when you can't do the visceral physical thing. So in Dreams, for example, you could grab the sun and move it, or you could open up a tweak menu and move the time of day. And it turns out that both modalities are useful. Like the Blender and the Rock are both useful, and Dreams had a bit of both. But they also appeal to different subsets of people. So you can't even statically say this is better or worse than this, because it's like for Kareem, he's never going to, like, he sees a tweak menu and you start losing him, he starts fading away. And that's a shame, because Kareem is one of the greatest, you know, great Dreams artists full stop. But Dreams people, you want to be on board. And so you don't want an aircraft cockpit to lose him. On the other hand, you have brilliant people who can use node graphs, you know, Blender geometry nodes and Dreams logic and circuits, and build these intricate. They were able to hold the abstraction in their head and then like build up the thing. And as coders, like I'm more comfortable with code than I am with a noodle graph. So whenever I see a noodle graph, I just see annoying ergonomic irritation, because I can wire A plus B to a plus node, or I can write A plus B and it's 3 characters in a text file that I can now diff and use tools with. And so, but it's just different people. It's just different audiences that respond to those things. But in all of those modalities, we can have immediacy, and I think the thing that everyone has shared on is like, if you don't have immediacy, you're going to have a hard time. I would use bad words. I probably already have, but I would use more bad words to describe the long iteration time. Yeah, slowness.
Yeah, just like the useless slowness. So there's a term that I came across very recently. I shared it with Kareem, and he was like down with it, so I'll share it with you. But it's from a woodworking book, because like, as all programmers, I'm now like transitioning into woodworking.
llama farming and all that stuff.
But the term is workmanship of risk, which I really like, versus workmanship of certainty.
Whoa. Say it again.
The idea being, yeah. So it's a book. It's a woodworking book. I can pull up the title later if people are interested. But the feeling of this like immediate, visceral, direct manipulation is like akin to when you're wood carving. And every stroke is sort of
carries with it some risk of you're going to chop the finger off by mistake.
Weight, right. And there's no undo in RL, right? But like even with undo, there's this feeling of gravity when you're doing these immediate kind of decisions. That's what Kareem likes, where it's like every stroke compounds on itself, and he's not the kind of person that like wants to undo anyway, because he deeply philosophically understands that part of this process is this like going forward and rewriting. Yeah, and so the term this person uses is workmanship of risk, meaning that the definition being that at any point during this workmanship, the piece can be ruined by a single mistake. And so in it, there's this like built-in craftiness of like, oh my God, this person did it. And you, like intuitively, the person can kind of feel that, okay, if this person like dropped this pot or like cut too far, the whole thing would be ruined. And it's like the Michelangelo like marble carving where it's like, oh god, I chipped the nose off. So that's like the epitome of like workmanship of risk. And on the other hand, he considers workmanship of certainty, which is not a worse thing, but it's the way you want to produce like 1,000 chairs because you need a repeatable machine. And it's sort of like the jigs that woodworkers make are like in that vein where they want to make a jig so that they're going to, whenever they need repetition and the risk is not part of it. So he makes this like separation. And so the nodes and the tweaks in some sense to me feel like this workmanship of certainty where you want to revisit your decisions and make sure you really dial it in. And sometimes that's what you want, especially if you want consistency. And part of why I think, well, music, anyway, I'm not going to even talk about music because I don't understand it nearly as well as you do. But like part of I have a theory of why the tweak menus show up more in the music. And it's partly because of the necessary repetitions and things. But anyway, those are terms that I'd like to propose as workmanship of risk is this thing that Kareem likes. And it has this like, oh God, I placed the thing in the wrong place.
I think some
as opposed
to sorry to take you've pushed a bunch of things onto my stack there, but like one of the things about I'm surrounded by Euro rack. I have a hobby obsession with like building little things, and they're covered in this. I've picked up this is Ectocore, which is hilarious. This comes from a forum post where someone was like, "What if there was a module that had two knobs? One was Amen and one was break." And if you're into like music, you just know that the Amen break is like the most famous drum break ever, and there's this whole genre of music called breakcore. And so out of a joke meme on a forum, Isaac from Total made this thing called the Ectocore, and you just have like the break knob and the Amen knob, and it's like the more intense. But so this is a perfect example. Actually, I hadn't intended to talk about this, but why is it knobs, right? And I think there's an element of just it's not repeatability. I don't think the audio is necessarily whatever the opposite of risk is. It's
no, it's not.
But it's
not
the work
always,
product is much more abstract and ephemeral. Like a sound happens and then it goes away, and so you need that repetition just because you need to be up to. You need to it's experiential. Whereas when you're sculpting or painting, you can kind of look at the thing in front of you and it just is like the thing that you're sculpting or carving is, and you can look at it from different sides and you can go. Whereas with sound, it's like it happened and then it went, and then you're like, well, I want to. And then the other thing is that the parameters that you're tweaking, when you're playing with color, for example, is much more viscerally physical. It's easier to visualize in a visual format because it's visual. Whereas, the amenness of your break is a harder thing to visualize. But what's brilliant about, you can have good sliders and bad sliders, and not all of the ones in Dreams are good, and some of them are good and some of them are bad. And the difference between a good knob and a bad knob isn't visible from the knob until you touch it and you feel it. And a good knob is one where it's like you instinctively understand the parameter space, and you start like feeling and exploring, and it becomes a feeling of like your body, your brain sees this as an extension of your body, and you start exploring this abstract space of sound. And so it is possible to have a slider interface which is wonderful and Kareem compatible, Kareem and Anton approved, tick, but only if it lets you explore a space in a non-annoying way. And anyone who's used an editor in Unity or 3D or Studio or Blender or anything else knows what the bad ones are like. The bad ones are almost whatever you do, you get a black screen. You move a slider and your object moves 500 meters off the screen and you've lost it, and now you spend 10 seconds, and those 10 seconds are crucial because now you're out of flow. You've ruined yourself. You're going and finding it. Or you're terrified to touch that slider because if you click it, there's a 20% chance that your program's going to crash, or that there'll be a big reload, or it won't be deterministic. And so there are ways that you see this UI and you know that knob there, and that's the evil knob, because if you touch it, bad things will happen. That is a bad knob. And then a good knob is one where you're like, oh, I really am enjoying just dialing this in as like 10% more. Oh, that's just so juicy. I love it. And so there's layers to this basically. It's like,
So I think this is why like you were frustrated and also slightly upset and hurt when Kareem would like go off. Kareem or I would be like, it's just a wall of sliders, and you're like, no, these are tasteful sliders.
Or at least I'm trying.
Like, it's sliders. It's all
I
sliders.
haven't achieved tasteful
and you're like,
sliders.
I poured my heart into this. We're like, Alex, you failed.
It's like no, exactly. And I didn't always achieve it. And I had a.
But you can't tell. Like, I think your point is super, super duper important, because you cannot tell from the wall of sliders whether the slider is a good one or a bad one. Whereas from the tool, because you're watching someone sculpt, somebody can actually tell like if it's a good one or a bad one, because like if they see a bunch of menu navigations, like the canonical example we always used to have is like if you speed up a time lapse of like Maya, and you just see like how much of it is actually moving the surface versus just like like windows opening and just like, and so we would grade like UIs based on how much of the time lapse like was actually things happening versus fiddling. And so you could see it, and that sort of is the indication. But with audio, you can't, because like, and I think it's just like on another crucial point, which only became apparent to me later, is like Kareem is effectively spending time to add quality and layers to a piece, but that is only possible in an immediate way because his thing is frozen in time. It's a sculpture or a painting. And so you can kind of noodle, and you're spending your time to kind of like add detail, but with music you can't. Music add is
plus 100. But here's the thing, Anton. So there's two extra branches we could go down here, like of different topics. One is that this applies to coding tools massively. I wanted to touch on that for a second. Like,
just agree.
And then branch two on that is like
success.
There's a, and this is something that I haven't figured out yet. But one of the things I dislike about noodle graphs and bad code as well is it doesn't, as you accrete stuff. So when we watched Kareem sculpting, for example, or painting, he's happy to just accrete more strokes because it doesn't go to like heat death. Whereas in code, if you just keep adding junk in, or if you're like vibe coding and just like going round and round and you're adding more and more and more and more stuff, like
LLM branch
it just degenerates, and it is. And with a noodle graph thing, inevitably the first three nodes are great. You watch a tutorial and it's like, I can take a texture and I can blur it, and then I can multiply it by red, and now it's a blurry red thing. But then you keep going, and at the end of it, it's like write-only code, right? Like you've created this monstrosity, and you can't do accretion. And one of the things I've been thinking about is like, what are the interfaces we can build for ourselves as coders or artists or creators or whatever, where accretion isn't a bad thing, and where you can just keep going, because then you don't need undo redo. This is a reaction to early point about undo redo. Right. If you can keep accreting, then the woodwork of risk is okay, because you can be like, well, I chopped the finger off, but now I'm just going to reshape it and keep going and keep going. But so on the coding tool thing, a discipline I keep like beating myself up about, because I keep forgetting this, is people talk about like hot shader reload or fast code iteration stuff, and like, yes, everyone knows it's good, but it's so deeply good that like, and there are like inflection points, and there's an inflection point at like sub 100 milliseconds that most people never experience, but when you experience it, it's like people who've experienced live reload experience the sub 100 millisecond branch, right? You have the 1 second branch, the 1 minute branch, the 1 hour branch, and what I'm trying to force myself to do at the moment is like, if I'm finding myself doing something repetitive, like I'm debugging a bug or I have some issue, and I've seen this so many times in myself, I wish I could like hover over my old partial. Right, you boot the thing and you've got a bug, and it's like when I go up to the door it doesn't open, or when I click the third link in my website the database doesn't load one time in 3, or so you're fixing some bug, and the thing what you'll forget is it takes you 15 seconds to recreate that state. So every time you iterate, it's not just a compile time. It's like, now I have to get the thing back into the state. So like I have to navigate the main menu. I have to load the level. The bug is on the third, branch. There's blah blah blah. And save games help. But even if you're going down to like load game, pick the slot, load, wait 3 seconds, that is awful. And it can be so much better. And I keep forgetting. And so the other day I was debugging a bug where I had to basically hit make, enter, alt tab, and then I had to like press F1, then I had to load a file, and then I had to make the crash happen. And I was like, what am I doing? I haven't got the tooling here to make this non-awful. So I went off for an hour and I just serialized enough state that basically when I booted the game, well, it wasn't a game, but the thing, it would immediately be in the state that it was like 1 click or 0 clicks away from the state that I needed to be in. And suddenly the bug disappeared. Like I squashed the bug. Like, and as coders, I just constantly forget that I'm slipping into the 10-second thing, and you can't measure it just as compile time. It has to be like time to reproduction. And I'm going to share one. So sorry, I'm talking too much. But like, there's so Dreams was an interesting development of a game. Like it took a long time, and one of the I was working mostly on the engine, the audio engine, and then the servers. And in 2015 I gave a SIGGRAPH talk, which is called Learning from Failure, which lots of people seem to like. So if you haven't seen Learning from Failure 2015, I think I gave a reprise at Umbra Ignite, so you can find it on Media Molecule's YouTube channel. Anyway, so I came back from that. I was like, yeah, Dreams is done. We'll just ship it. It's done. And then basically Dave Smith, who's a very brilliant. I don't play games much, so I don't get involved in the game design aspects because I don't know what I'm talking about. So I know my limits. I'm graphics, sound, network, but not gameplay. So Dave was responsible for gameplay as a tech director at the time. And he was like, the velocity on the team isn't great. The code base isn't, it doesn't. We're falling into this trap I just described, where like iteration time is slow, bug fixing is slow. There are memory leaks. There's things that are bad that are happening. And so, can you help? Can you? I don't want to do this. I'm a game designer. He's a coder. He's a brilliant coder, but like I'm not into the idea of fixing this. So like, can you fix it? So I looked inside Pandora's box, the game code, and I was like, my God, my eyes, So we started again. We did file new project. Never ever do this. It's a terrible idea. And the producer called it Unicorn because it was like, it'll never happen. She's like, fine, Alex, you can go off with Liam for 2 months. It took longer than 2 months, but like, go off with Liam, who was a very brilliant young programmer, and make Unicorn. And it's a unicorn, so it's never going to exist. But like, do your thing. And there were lots of things to talk about with Unicorn, but the one that's relevant to this is I made it so that asserts were non-negotiably hard crashes even in release build, with a core dump and a TTY. So like, if and then I tried to explain to people that you document invariants in the code as an assert. Like you can scatter, like don't write a comment, write an assert that like validates, and then you have to teach people that you can never ever assert on like data or user input or network input. So it's about invariants. Like so, even that was like. This is obvious stuff, but it's not something that was done in practice at Media Molecule by myself or any of my peers. So we suddenly tried this out where like we're going to document things as asserts. And asserts will stop artists from being able to work. So an assert is like... and to give you the motivation of what I'm talking about, the other day I saw a tweet from somebody that was like, I have played Dreams and created in Dreams for 5 years and I've had 2 crashes. And it's not... And we had no tests. No unit tests. And how is this possible? And but I didn't know that this was going to pan out. But I'm doing this with the benefit of hindsight. I was like, that's the best accidental choice I made ever. Was like so brutal asserting, and then I made it so that when it crashes, we also had bit accurate determinism. So we'd even test this by having two copies of the game running, and it's a functional reactive thing, which is something else to talk about. But basically, the entire state of the game is stored in a variable called G, a pointer called G. That's like a single block of RAM is everything of the entire game. Like there's actually a few pools and stuff, but conceptually there's like one object. And in order to create the next frame, you take last frame's G, which is const star G, and then you have a non-const writable G, which is next frame, and all of the game code runs and just creates a new writable G from the old G, purely functional. And the only input is the old G and the USB packet of like what buttons are being pressed. That's it. And so the whole thing is like a giant shader, if you like, and it's difficult and it has downsides and problematic, but that's great because it means that you can, for example, hand it off to a renderer thread, which has we have a little round robin of like the last few games, so we can interpolate. The audio thread is like, you just grab a const G and it's immutable, so now you can just like go and pull out all the state of the audio engine, and it's very simple because it's read only. It's low bug risk. But I'm not even done yet, because then we tested by basically every frame, we just forked 2 threads, or 2 groups of threads, and they both run the game, and then they compare the results. If they're not bit identical, then we have a determinism problem, and you immediately assert, and everything stops. So now you have like on-the-fly testing of determinism every frame. Then you make it so that because it's a UGC game and everything is an editor, the first thing you build is undo redo. The first thing you build is save and load, not the last thing. So everything is serializable. Everything is deterministic. So on crash, it saves a screenshot with the core dump, and then in the end of the PNG, because you can shove bytes after the end of a PNG, I then just serialize the entire state of the game, the last game that successfully ran. And then I send it to it automatically creates dumps it onto the network, and then you can create a Jira ticket or whatever your bug tracking thing is. The point is, as a programmer, to finish this whole arc, in order to reproduce that bug. So I get a bug saying it crashed. I'm very angry with you. I was sculpting my greatest creation and it crashed. But here's a crash dump, which looks like a screenshot. I can immediately see from the screenshot in the email what they were doing. They're holding the hand over sculpting the eyelid beautifully. And I load it onto my dev kit, and without any clicks, it loads into exactly the frame that last successfully ran. and then proceeds to run the next frame, and 9 times out of 10, it would just immediately crash in the same way that it did for that person, because it's perfectly deterministic. And so my repro time from get crash report to in the debugger with the crash, and I can do it as many times as I like. I can go and rerun that frame as many times as I like with zero effort. Now, I'm saying again, I'm not saying I'm such a genius, I thought of this before, I didn't. But the net result was our velocity on bug fixing went absolutely through the roof, because there was, as I said, there were lots of downsides to this approach to don't immediately go and re-rate your game as functionally reactive. There's parallelization problems, there's cultural problems of like it's an annoying way of writing code, there was lots of mess, a lot of the code was difficult to understand, there were lots of downsides I haven't touched on. But for the specific problem of getting to the bug instantly with low, high reproducibility, there was unreproducible bugs were extremely rare. Like extremely rare,
right? And it's because of the non-deterministic thing as well. It's important, right? Because otherwise, when you get to that thing, maybe only 5 out of 10 times it would crash. But because anything non-deterministic was also crashing, it
exactly. You couldn't do non-deterministic.
And then the other,
yeah.
And I think, it's probably a separate point, but a lot of people think about this and like, oh, but the artist lost their work, and you're like basically sacrificing the artists as QA. But it's like, well, no, because everything's reproducible and replayable, their work's not lost. You can recover it. So they lost nothing. They just got frustrated in the moment that the thing crashed. But even the crash is not that big a deal, because they just reboot and they're right back where you started. And the crash, it will go on the network and somebody will get notified. So I think oftentimes I get told but we must do continuous integration testing and all this stuff. And I'm like, well, you don't must. You could. That's a thing. But there's this other thing you can do. You can do this other thing. They're like, but that won't work. It's like, no, it totally does work. Because look, Dreams is non-trivial.
I should say also, it saves, I think it also in the PNG, it saved a snapshot at the beginning when you booted the game, and it also saves every packet from there. So you can, and then the end crash state. So you have the start snapshot, the end snapshot, and all the packets in the middle. So if it turns out that the problem was upstream or happened 10 seconds ago because of some bug that then propagated through time, that's fine, because you can just go back and you can start from where they started and then watch the game play back in real time. Unfortunately, it's not much faster in real time.
So how much of this was recorded then in this crash stuff?
Everything, because it's literally like a controller packet, which is like 8 bytes or 2 analog sticks, 16 buttons,
so all the
and
inputs,
a gyro.
Initial state, all the inputs, and then the actual state when the crash happened.
At the end, at the crash, and so you can load into the initial state and play back, or you can load into the final state, and between those things, you're always able pretty much to. There were problems where we didn't record network input, for example. So one of the if I could improve it further, one of the things that wasn't recorded was network. So once we started adding more stuff relating to the server, that wouldn't reproduce the same way, and so it worked well when it was in a hermetically sealed box, and but ironically, actually, a lot of the sculpting, creating, playing single player experience was enough to debug all the systems. Like you didn't need to test the case where there was external. It's harder. Basically, what I'm saying is if you can put a line around your system and say it's hermetically sealed and the only inputs are this, then it's great. But it turns out we could do that for a lot of it. And there's another topic I don't know if you want to talk about. So another proposed topic is, so Dreams was fairly traditional entity component system type thing with this functional flavor on top. So you had what we called things, which were just game objects, and then they had parts, which were and then you'd actually have so you'd have a physics part if it was a physics body, and you'd have a sculpt part and a sound part, and they were all stored as structure of array. So you'd have an array of a flat list of the physics parts of classic ECS stuff, with the twist being that there's no such thing as deletion or defragging, because you basically recreate all of them at the next frame. So as an example, how you delete an object in Dreams is, so Anton is making an editor, and one of the things you might want to do is select all and delete, or you select 15 things and hit delete. Well, what happens is that literally the game tick is they are pressing the delete button, and they are in the the right mode for deletion. And as I walk through every game object, creating the next frame's version of it, if it is selected and they are in the middle of pressing the delete button, I just won't copy myself. So deletion becomes the act of not copying yourself forward into the next frame, because everything is recreated from scratch every frame. So, and there's never any fragmentation, and everything is in cache order, always, because the order you process the objects is the order that they're written into the next frame's frame. So basically the memory accesses always look like sweeps through the thing, even as stuff is reordering itself, because if you need to go and visit a particular child in a particular order, then you will go and visit that child on this frame. It'll be out of order and you'll get a cache miss. But on the next frame, it'll be the first guy that gets written into the next frame's list. So naturally, things kind of topologically sort themselves into cache coherent order. So that's kind of very nice. And so,
except for gadgets, I guess.
So gadgets
you have to topos.
Well, interestingly, the evaluation of gadgets, which is the node graph, itself is topological because you go and evaluate who's upstream from you in the wire.
Are they in topological order when they're stored in the thing, and you like topo sort them?
I think there was an explicit topo sort at one point, but conceptually you could.
Because I tried the you can do on the fly topo sort. I did it for modeler, but everyone just quit.
There are problems where cognitively there are these hidden constraints that you're adding in, like these kind of contracts with yourself about the order that things are traversed in and how you handle loops and stuff, and they cannot be obvious, and it makes the game code very non-traditional. But what I was going to get to, which is really unusual, is that in a Golden Path game, you have assets, right? You have textures, meshes, models. You might build an art pipeline, and by the way, that's always a cursed thing. Like building a stable build pipeline for art assets is really hard because there's just art assets are wild. They're just you've got a 16K by 16K TIFF that's like 32-bit float, and you're using that for an eyeball and all this stuff. But so the thing is that people think about entity component systems or game state systems, and they think about constantly changing small things. But then there's just this assumption that textures appear from out of nowhere. You load your game and all the textures are there, and it's not really part of the mental model of. But if you're building a sandbox game, there aren't Dreams literally has only platonic shapes, sphere, square, circle, triangle, and no textures and no meshes and no assets. The only assets are audio. In the traditional sense of asset. So how do you handle heavyweight stuff? So for example, Dreams will take a sculpt and will run compute shaders and generate a signed distance field and give you several gigabytes worth of stuff that you don't want to recompute, and you want to cache it. So you have to cache it. Everything in computing is cache and validation and naming and off by one errors, all that stuff. Anyway, but we had to deal with the problem of this is an editor, so Anton is going to go in there and he wants to be able to grab anything in the world, any edit, the glasses, he wants to be able to move them. And I'm not even talking about an object. I mean, embedded in the sculpt of my face, he decides that he's going to pull my glasses forward, which causes a cache invalidation, which causes a massive amount of recreation. And then, worse, the artist wants to be able to take my head, clone it 400 times for some stupid reason, and then change the glasses colour on 50 of them, but not on the other. And Anton took this even further at Adobe, but on Dreams, we had this middle ground. So I saw this spectrum of different data structures. You've got entities which are constantly changing, so it makes sense to just recreate them every frame. Then you've got WAV files, which you recorded once with a microphone, which never change, and which you want to use a content addressable store, immutable, all that good stuff. And yes, there's caching, but it's never going to change. And then in the middle, you have this horrible nightmare, and that's where you get into sort of database territory, where you want. So we actually literally Dreams builds Merkle trees. So it's basically trees of edits. So if you have a list of edits that aren't going to change very often, they're going to change once every few seconds if an artist is in edit mode. So we bundle them into these trees, which are then hashed, and then we do copy on write. So basically, as you clone my head, I only clone the root of the tree, and then they're all shared, so it's actually a DAG. And then as you edit some particular part of the tree, it's like a B tree, and you're getting copy on write, so you're spawning. So it's classic functional data structures, functional B trees, those sort of things. And these things, these database concepts, apply massively anytime you're building an editor. If you can build a powerful enough data structure that lets you... So entity component system is just the beginning. It's if you enjoy thinking about that stuff, start thinking about what it would take to build something where any texture could be scribbled on. If you want to think of a traditional game, or where you could go and grab any mesh and start pulling the vertices around, and what does that mean for your game? And it would be different for different games, but maybe you want to clone that mesh, but then you want to abuse it. So the other difference is early Alex, young Alex, I was very ginger. When I made a system, I would poke it very gently, and I'd be it still works, great, check it in, done, go home. And then late stage Alex is, I can copy it, right? Okay, select all, copy 900 times, make 2 to the 64 objects, see what happens and see how it explodes. And you want to do that latter thing of just utterly abuse the thing you just made. So and the satisfaction you get from building a system that gracefully hits limits or pushes back on you in where okay, you've run out of memory now, but I'm not going to crash.
That's a good strategy for a lot of things, like not only
Yeah.
like sandbox user generated content games, right? Like any sort of system that you're building and you kind of realize, oh, I need to test it at some point, and you test it. It's like, okay, what if I like spam this button? What if I spam the
Yeah,
button
yeah.
in sequence,
Dare to do it, and every fibre of your being will be telling you not to. Like if you've just crafted some new system, the last thing you want to do is fail, because you want that dopamine of like, oh, I made this awesome thing and I can walk around my level and my physics engine is awesome. But what you actually want to do is take 5,000 chairs with a really awkward shape and then fire them at 300 kilometers in the ground into each other, and now your physics engine falls apart. And yeah, it feels bad for a bit, but like that's what you want to do. And I learned that from Dave. Actually, I learned that from a bunch of people who were better at that than me. Like I'm the person who instinctively just does a cool demo, cherry picks it, and sends it to the office. Look at this cool thing I did. It's so cool. We've now got, and then then immediately Dave or someone will walk over and like break it in 2 seconds. And
I feel like that's like half my job as a UI programmer, and that's why like the artists like me, because like when an engineer that wrote the system writes the tools for it, they're gonna like subconsciously or deliberately or whatever make the UI very ginger. Because they're going to be like, well, we can only handle 20 of these. So like, they won't even do this deliberately, but they'll be like, they won't even think of making a tool that lets you like just spray these things. Cause like, that's just a little scary. So half my job is just to come in and make the worst UI for the engineers and like the best one for the artists. And the artist's like, yes, thank you. Why didn't they do it? It's like, well, of course, because the thing crashes
I think there's a discipline that I learned moving from
like,
the PC world to the console world, which is where you move from like virtual memory to hard drives to, everything is fixed and there's no virtual memory and there's like X gigabytes and you're done. So one of the best disciplines ever. I think I saw a Casey chat once where I think it was like a billion row Java performance challenge chat that he was doing, and he spends a ton of that doing what at Sony. The Mark Cerny, the guy who's the chief architect of PlayStation, is brilliant at this. Is like back of the envelope speed of light calculation. It's like, okay, you want to do counting rows of Java billion line row challenge or whatever, or you want to do a game where you can do destructible environment. And so we're talking about abusing it and pushing it. But before you've written a line of code, what you've done beforehand is you've done like a speed of light analysis of like, what can I afford within the budget of time, memory, blah, blah, blah. And consoles are very brutal with budgets. Like you've got 16 milliseconds or 33 maybe, and you've got like X gigabytes for this system and nothing else. And like it's just utterly hard. And so not only do you learn to like abuse it horribly, but you also you decide up front what your boundaries are going to be. So it's like, what is a reasonable limit on this? Like as a PC coder, I was way too happy to just be like, this is a stood vector and I can just keep pushing back on it until the end of time. But as a console programmer, you're like, I have to decide up front what the limit's going to be. I could get it wrong and I'll change the limit in the future. But I'm like, no, I'm going to engineer this so that the limit is 1 million, but also it runs well up to 1 million.
Oh, yeah.
Whereas the PC Alex would be like, it works for 10, it goes up to infinity.
It must work for 1 million. It must.
It must work. I mean, I've never tried more than 11, but like, it's probably
and if
fine.
It doesn't, get
so
more
maybe,
RAM. Like, stop
what's
being so
that old
poor.
blog, Accidentally Quadratic? I think it was some like GTA loading time thing where they were like, it's a blog post where he collects all these algorithms that were accidentally quadratic, and they were only ever tested in the shallow part of the curve, right? And then like at some point they push it beyond the parameters and it goes like this. So this idea of like speed of light calculation, I learned, from Sony and from working console, and it served me so well. Like,
I think it's the only truth. And people I've talked to people on PC afterwards working on console. They're like, oh, you're too used to working in like memory constrained environments. You're like too concerned. It's like, no. This is actually just good engineering, because when your stood vector fails to push, what's going to happen? They're like, well, it's going to throw an exception. Who's catching the exception? It's like, well, I caught the exception at main.
No, and there's soft pain.
Well, it prints
there's
error.
There's soft pain before it.
Ultimately goes back to the user. Yeah. And the user is just going to get either a crash or an unrecognizable error. And it's like, if you want good UX, and this is like my whole UX. I'm a UX programmer that writes in C rant. Is like, I want the error to the user when you push back your vector too much to be sensible. And ideally, there shouldn't be an error. So like, I'm coming at it from that perspective of like, I don't even care about like the program consistency or whatever blah 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 arguments. Like, no, when this thing overflows, I don't want the thing to crash because I don't want the user to be unhappy. And if it does crash or halt. Like it needs to print something sensible. Like you need more RAM to do this, or you need to change your config to be 4 million
I want
instead
to
of
emphasize
whatever.
this because like maybe people didn't get this right. Like the idea of this like a lightning speed calculation is instead of having a algorithm to do something and then trying to make it faster than it is right now, you sort of step back from anything that is like code related and you think about, okay, what am I actually doing here? Am I loading a file?
Yeah.
Okay, so what is my SSD file load speed? And then you realize that, oh, actually I'm loading this file for some reason at like 1% of the speed that the disk allows me to. So what's going on? And then you start to dig in deeper.
And you can apply this, exactly, and you can apply this at all stages of development. So if you like, another way of thinking about it is often as a programmer, you don't want to think about the limits because they're typically hard, or you don't want to think about the scaling, whatever. But actually the blessing is that normally there's a human at the end of this, like using your website. There's some scale you're planning to operate at. Like, I'm going to have this many users, I'm going to have this much concurrency, I'm going to need these many objects in my game. And you sit there and you just make rough estimates of what the hard case is. And then you think, what can my system handle if I was amazing? And then you say, look, I'll put 10x in for me being not amazing. But like, is that still good? And can I hit that? And then later down the line, when you're only hitting 100th of what you expected, you're like, well, I mean, why is this so slow? And then you know when to ask. But conversely, you can be like, this is behaving exactly as I expected. And yes, I am sending a 20 gigabyte file over the network. And yes, it's going to take this long. And there's no point optimizing that. Or you can step back and look at the problem. And the thing about SoftPain is like, I'm sure you've all done that thing where you've got a file that you need to load into Maya or even a text editor, and you know you're scared because it's a 3 gig file, and you hit load, and not only is it going to take a long time, but there's not a guarantee that the machine will be alive at the end of it, right? And it's just you're just like, oh my god, the whole machine's going to grind to a halt, and that comes from.
And that's the same thing as like changing a header file in C++. Be like, I don't want to change this because the compile times are going to be 30 minutes.
Normally I find that stuff comes from systems that haven't been written with this kind of speed of light thing. I would rather have it up front say, this is a 3 gigabyte file. That's probably beyond what I can do, or given your current RAM, like there's, as Anton was saying, you need good error messages. But because the architect who made that in the first place was thinking in terms of limits, in terms of speed of light, in terms of what a sensible computer can do, the whole mentality of writing that code and that UI and that interface to the user is more likely to kind of convey where the limits are. Because sometimes you can't do infinity. Like, it's almost like anytime you imagine yourself writing something and you're like, this goes forever. It's like, no, stop yourself. Like, where does this stop? Where does this usefully stop? Where can you stop worrying? Like, I can do up to 1,000. Beyond 1,000 doesn't matter. And if I see something coming down the pipe that's more than 1,000, I can assert, warn, log, whatever the hell. And yeah, that's it, really.
I think it makes it. I think the reason we avoid it as programmers, frankly, is because it like kicks us out of this abstract, beautiful mathematics world where like my algorithm works till infinity, and then this kind of thing forces you to think about the non-infinity, which is really like for sure the reality of things. Like for Modeler, we have a hard limit of 1 million nodes, and part of me still feels like, well, but what if like in 10 years somebody has a super GPU and they want to do 10 million? It's like, dude, just you're in the clouds at this point, right? Like, just ship a new version. Like, if the app still exists, ship an update for 2 million, right? And if the app doesn't exist, well, then like you're on to the next thing. So it's like, but I think we want to live in this beautiful, pristine world where things are not like, it brings you back down to the ground.
And even if you don't want to set a hard limit, because setting hard limits is hard. Like, this isn't all roses. Even if you don't want to set a hard limit, you can at least measure, and it's. I think this all comes back to the idea that you go and. I don't really want to use the word abuse, but whatever you write a new feature, you go and really hammer it. You really push hard on it. Test. But you test the hard cases. And it's almost like you test up to what your limit is. Even if there's no 10 million coded into the code, you know that you're comfortable loading this gigabyte file or that gigabyte file and that it works and it doesn't accidentally quadratically take 3 hours. And I wish I did that more. Basically, this is the Alex talks to.
I'm actually more and more convinced there should just always
maybe I don't know.
Like I have not yet found an argument for like.
Yeah, I don't know though, because
for everything.
I want to.
Like, even if that limit is a lot, like you.
Okay, but I think you have. If you make a limit in there, you have to promise it's good up to that limit. So it comes with a contract. Like, the bargain is.
No. That's probably where we depart. Where I'm like, I think you need to think of the limit as a sensible thing, but you can't, like, especially in PCs, because you can't, in consoles you can guarantee it because you know everybody's got the same thing, but in PCs you might have a potato box which can handle like a million nodes but can't render them, and so there, I think scalable stuff. And you mentioned Mark, by the way, just like as an example of this kind of like users, like my favorite thing for like the PlayStation 5 design from Mark Cerny, because like Alex was saying he was the architect, but like I remember him talking about like why there's an SSD. And if it was like a normal architect, people would just be like, it's an SSD because SSDs are fast and because we're next gen and it's an SSD. That's like Mark's approach is like he wants to prove to himself and as a byproduct to the company that this is actually important, because you don't want to put in an SSD if it's like going to cost you money. But he's like, go to the user perspective. It's like, why do we have an SSD? And it's like, it's because you don't want load times. You want streaming worlds. And people are like, how the hell is that connected? And he's like, okay, back of the envelope, you can work through. Like old games used to have these hallways between levels so that you can like load the next level. I don't know, people might not be aware of this trick, but like to prevent the like loading bar for the next level, old games would just like give you a hallway to walk down, and it takes you like 30 seconds to walk down that hallway. But because it's a hallway, there's very little assets. So as you're in the hallway, they dump the previous level and they load the next level. And like when you think about this, you're like, my whole reality is ruined, because you're like, I've had this continuous world experience, but like this is what's actually. Elevators are the same thing. Anytime you've taken an elevator, this is what's happening. And that's probably why the elevators in the level.
Especially the PS1 era, they're great at that. Like I think original Metal Gear Solid 1 or 2 was really good at that. So Mark, I remember the SSD thing.
So Mark was like, we don't want that. So that's what the feature.
Right. But the SSD point to make it really concrete. I remember the conversation with him. Now, I don't know behind the scenes how far. There was a famous Spider-Man demo. I think it was Spider-Man. There was an Insomniac demo for PS5 at launch time, where basically you could swing through the city in New York with just, and it was never loading. It was amazing. But before that came out, and I don't know what level of development they're at, Mark was like, right, okay, we want this many texels. It's like just back of the envelope, but it was like, this is the sort of mental steps you want to go through. And I heard him sort of repeat this out to me, and I was like, oh, holy moly, that is really interesting. He's like, okay, we have this many texels per millimeter, and they cost this many bytes because it's this compression method, and the screen is this resolution, and my mip mapping is this good, and I'm going to throw in a factor of 2x slot because I have to load things in pages. And he basically works through like a bunch of numbers that feel totally made up, but he's like, okay, as I move the camera at 1 meter a second, I will need to sustain this much bandwidth. In the very rough calculation, like I will be seeing with my eyeballs 1 gigabyte. I don't know what the numbers were anymore, but like I'm seeing 1 gigabyte a second,
some data rate.
But then he does a sidebar, like he goes, "This is not on a whiteboard, but you can imagine." And he's like, "Let's just stop and think about how many bytes of RAM can the GPU touch." How many bytes of RAM can the PCI Express bus? And he works backwards from like the game design mentality of like, I'm flying the camera at this speed with this texel resolution. And then he looks at like literally the PCI Express bus bandwidth, the SSD bandwidth. And then he's like, well, in that case, we need this compression ratio from the compression chips that like we're going to build. And
how can he be sure for the stuff like Spider-Man which is like...
No, so that's the beauty of it. You don't need to be sure. You just need to give yourself a sense of, within an order of magnitude, what could be. And the surprising thing is, if you haven't done this exercise, it's surprising how close you can get to the real answer. And then you go and build the thing, it takes you a year. And you're normally, if you're good at doing, like Mark is really good at doing this estimation thing. I've seen physicists do it. I've seen like, there's a discipline in science where people are like, well, it's kind of this order of magnitude and this order of magnitude, you multiply together and the answer is 5. And then you go and do a rigorous analysis or a computer simulation and the answer is like 4.7. Right? And you're like, but that you don't need it to be bang on. You just need it to prove that this is a thing that we're going to be able to do that we couldn't do before.
Because that tells you when you're close to something, because the thing Mark's trying to figure out is there a way we can actually do this? And then once he does this, he's like, this seems within reason. Now I just need to press on the SSD manufacturer and whatever. And then you get like the actual sustained bandwidth. And then maybe it's not enough to render the full Spider-Man because like they put too many graphics in their quotes or whatever. But like, at least it's like way closer than the opposite, which is like, oh, it's way over spec'd and it's like wasting money for the company putting this super powered NVMe thing or whatever. Or it's way under spec'd and then it's like, oh God, we need hallways again. But it's like this idea that you got to be like, that's what I mean by UI programmers. Like, I have to look at what the user's seeing, which is the user's seeing Spider-Man. They're like, I want to be Spider-Man. It's like, you want to be Spider-Man? You need the SSD.
Yeah, it's like,
and someone needs to draw that.
It's like being
and
what's that meme with like, help me budget this? You know, the thing where it's like, I got this much for this much, and then like $1 billion for this. And doing the speed of light calculation helps you be better at budgeting. Of like, okay, I have some concrete trade-offs. Of literally, in the case of Mark, he's like playing a way higher stakes than any of us are, because he's like deciding what the hardware is going to get stamped out times, you know, X million. But he's like, how do I spend my literal dollars and like, you know, the cost of a PlayStation and make it so that we can do interesting things like Spider-Man? And you wouldn't think that you could draw a quick back of the envelope through line from an idea like running through New York City at a certain speed all the way to PCI Express bandwidth, but you can do that in a 10-minute conversation usefully, and it works on micro level as well. So this is the macro. So like, have some numbers in the back of your head. Everyone knows the like speed of speed of L1, speed of L2, memory access, and it's like that thing of like, it's nanosecond for this and a lot of that. So the one I always had in the back of my head when I was doing PS4 development, I don't even know if this number was right, but it helped me sleep at night.
Is it 5
I was going to say
ALU
6, maybe it's 5. I was going to say, for every byte of memory I touch, I get 6 ALU op flops for free. Like, while I'm waiting for that byte, I can go do six additions, multiplications, or whatever. And that's what is super inaccurate. Doesn't matter. But the point is, it changes the way, as you're coding, it changes the way you're thinking. It's like, shall I DXT compress this? Well, yes, it's going to halve my memory usage. But now I have half as many floating point operations. Or the other way around. I'm going to go and fetch this texel from this texture that's 4 bytes. Brilliant. I've got 24 instructions I can spend for free while I'm waiting for that to come back. And again, it doesn't matter that much, but you start like understanding what you can you don't need, get away with.
It's not 1,000 and it's not 0. Like, because if you don't know, you're just like writing code. But if you do know this, it's such a simple rule. It's easy enough to keep in the back of your mind that you're like, I've been doing a lot of reads. Like, this algorithm reads like 30 things. I might as well do a bunch of ALU here. Whereas if you didn't know that, you would just do the algorithm, and then maybe you do the ALU somewhere else, and then you have to like later down the road realize, this is too memory heavy. I better fuse these passes. But it's like, you skip that by just remembering how many like ops per byte. I don't know if that's true on PC. On PlayStation,
it's harder because the hardware is different in every box. You know, everyone's different.
But even just that idea of just thinking, you know what, I probably have a few ops per byte.
I thought of a different topic that's kind of related to all this, which is like,
can I do one more?
Yeah, well, go ahead.
On the topic that we just talked about. Why do you think this idea on this, like this kind of measuring back on the envelope? I've seen it outside of game development, but not that much. You know, like I worked at already a couple of places, and nobody's interested in this really. Like outside of like, is there something particular?
Yeah.
Like I understand consoles, when you have limited stuff, you need to understand quickly. Are you gonna hit the limits or not? But you know, kind of like, if you want to be efficient with anything you do, you can run these numbers, right?
I think it depends on what what's important to you. So so for example, in the world of like AI, for example, when you're training and it costs you money, literal money per hour, you're more interested in performance. And there's this metric that's used, you know, MFU, which is like the something like the mean flop utilization or something. But it's like, you just get this single number that's like I feel like it's a sort of post hoc version of the speed of light thing of like, I expect my very expensive GPU to be able to do this many flops because Nvidia put it in a marketing presentation, and I am getting 5% of those advertised flops. How do I feel about myself? Is it my code? Is it the driver? But at least you have a metric to beat yourself with, and then you can feel happy when that number goes up. And I've noticed that actually very often you have to have a kind of end-to-end full stack systems view, whether it's AI or games or anything else. Getting that number up isn't just optimizing it in the loop. It's like Amdahl's law is everywhere. You want to go find the fat, and you go trim away the fat first. You trim away the easiest fat. But maybe one of the reasons you don't see this speed of light calculation everywhere is because maybe that's not the most important metric. Like, maybe efficiency isn't needed, you know, blah blah blah. We can horizontally scale.
I have a spicier answer, which is that it makes people sad, and people avoid sadness to themselves, because almost inevitably, if you've never done this or you're doing this for the first time, you're almost always going to be confronted with the sadness of how bad it is for this or that. And it's like, it's the shatterer of dreams because it brings you closer to truth. And like, you don't want your dreams like you want to live, like going back to my point about Stud Vector like gives you this promise of like, you never have to worry about the pushback, just push back. But it's like, you give that up and then you don't want to be confronted with what happens when you can't. And it's like, well, it's an exception. It's like, well, what's an exception? It's something you sweep under the rug to deal with later. And it's like your subconscious hope is that you kind of just don't want to deal with it, and somebody maybe will file a bug.
I think it's also to do with whether or not you feel capable to improve it. So this is actually bringing me to the other topic, which is like, I'm calling it outsourcing, but please don't understand that to mean literal outsourcing. I mean, you decide as a programmer, as everything's fractal. You're making some big product, and then like you're responsible for some part of it. And if you're a single solo dev, then you're responsible for all the parts of it. And on different days, you'll be wearing different hats. And you're solving this big problem of like make game to become billionaire because best game. You know? And then fractally, you get in, and at some point, you decide to outsource. You're like, I will use Unity or Unreal because it does not make sense for me with my skill set today to go and make an engine. So I will outsource the engine to Unreal, and that's what I mean by outsource. It's like I conceptually carve that problem out and give it to somebody else. And I was talking a little bit before the stream about this with Wookash. It's like you are making a choice there, and there's no like the handmade attitude that I love, and the handmade sort of movement, if you like, comes from people who are trying to push people to measure the cost of outsourcing differently. And I think people sometimes under-index the cost of outsourcing something. And the reason is because when you get to the speed of light type calculation, there's no point doing the speed of light calculation if you outsourced your rendering or your database or your whatever, because there's nothing you can do. Like the physics engine wasn't written by me; it was written by Havoc, and so or whoever. Like it doesn't matter. I'm not beating on Havoc, and yay, I got Havoc, and it allowed me to make my game, and I shipped it, and it's like existentially a good choice. Or I decided it was important for my game to have 5,000 crates or 5,000 chairs firing at the ground, and it's not performing or it's behaving badly, and I don't know how good it could be, and I can't even do the speed of light calculation. How many chairs should I be able to have in a pile? I have no idea. I outsourced Havoc to somebody else, and I don't even know what the algorithm is. I don't even know what the order n blah 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 is. And so the reason I think you see the speed of light calculation thing happen amongst handmade type people, amongst game dev people, especially game dev people who build their own engines, is because they feel able to understand the stack far enough that they can go do that calculation and then put expectations against their own. And I suppose you can use it to beat up an outsourced thing. You can say, well, I'm writing 1 gigabyte a second of writes to this database, so it should be able to handle it on the $9 million cluster that I'm paying for. And so maybe it is helpful there, but like the cost of outsourcing is. I
mean, a non-programmer. You were saying outside of programming, like a classical version I've seen of this is like in the climate change stuff. There's like a book called Climate Change Without the Hot Air that I really like. Brett Victor gave it to me, and it's like, because I was like doom and gloom over climate. No, it's like I was sad, and I went to Brett because he was running this lab, and I was like, Brett, what should I do with my life? I want to help the world. And he's like, read this book about climate change. And he like set me up with some climate change people, but it's that, right? It's basically, it runs through the world power, and it's like, look, here's how much power you need. Here's like how you can make that power. Like if you have mountains, you can make a dam. If you don't have mountains, you can't make a dam. Like there's that sort of level of thinking. And then after you read it, you can like, I'm very pro climate, like obviously with my green shirt, but like you can talk to people and they don't like, other climate people don't like it because they're like, no, but I want like solar to solve everything. It's like, well, it can't. Like it really just like it doesn't do it unless you're in space or whatever. So I think there's that same feeling of discomfort and sadness because you want to hold on to this idea that you believe will work, but like you don't want to be confronted by the raw physics or the raw numbers or the limits because you just want it to work.
Yeah, wishful thinking.
And it's like you could even be on the same team, like performance-wise, be like, yeah, we're both using C++. It's like one person believes in Stud Vector. Like they believe in,
just
like,
to lighten the mood. I remember
whatever,
I was so punchable. I'm amazed he didn't punch me in the face. Actually, it was like the end of Fable 1 crunch. So it was like Xbox. Whatever, not one, Xbox original, and it had a hard drive, right? The original Xbox, but they wasn't allowed to use virtual memory. Anyway, they had run out of RAM. Basically, they were just getting out of memory errors, and like they had weeks to gold or whatever. And I was by the tea point making tea, and I wasn't working on it directly, and they were like, "Oh, we're just running out of RAM. I don't know what to do. Blah, blah, blah. I don't want to be confronted by." This is what triggered it. Like, I'm confronted by the hard limit of the amount of RAM that I have on my thing, and they'd fallen into the trap of like dev kits had double the RAM, so they were like, "Oh, we're fine," and then like, "Oh my god, we've got to halve it." I was like, "Use smaller ones and zeros, man. Just use little digits."
Wow.
And he just looked at me like, "Oh yeah, I just was such a what a little douchebag I was." But sometimes you want wishful thinking. You desperately want to be able to go back to your desk and be like, I could just use smaller ones and zeros, and then it'll be fine. As it happens, I believe an amazing engineer from the demo scene who worked at Microsoft at the time re-enabled virtual memory around that time. I don't know whether it was because of Fable, I don't know what the cause and effect here is, but around that time virtual memory became a usable thing on the Xbox, and so Fable was like saved basically. And they're a brilliant team, they probably could have got there, but their journey, physics was changed, a wormhole was introduced known as virtual memory, and they no longer had to confront the in quite the same way. So
I mean, I think your point is like super valid, and I think I've noticed this myself whenever I try to do on the fly, like constant performance analysis on my code. I become like more risk averse. You want this naivete of like, I'm gonna do 4 billion units, multiplayer, and like you almost want that to start the project or something, and it's, I don't know, it's sad to do the thing and be like, no, that won't work, and like you have to be careful that you didn't screw up the back end of the envelope, because like it is the truth and you won't beat it in some sense, but if you did it really wrongly, you might discourage yourself by like an order of magnitude.
Sometimes it's nice to be ignorant.
And so sometimes like Alex, you talk about this sometimes, Alex, where like you imagine that like this game did this effect somehow, right? And you imagine like a more pure version of it, and then you actually write the more pure version, then you talk to the programmers and they're like, no, we just like hacked around it, and it's totally this smoke and mirrors, but like all of a sudden you got a SIGGRAPH paper because like you actually solved the problem because you thought it was already solved. And it's like, so sometimes you want that blissful ignorance of like, no, this.
I remember there's
so I think
there's a good story from before the internet. It was much harder for information to flow around, and I think that Quake was happening, and I was at Bullfrog, and my job at the time was writing inner loops, polygon fillers, like software GPU, because it's pre-GPU land, and it was really fun because it's a really constrained problem, and you can make number go down, how many, and the demo scene was great at this as well, like how many cycles does it take to texture a single texel, right? And word came that like they had a perspective correct polyfiller for Quake, and we're like, oh my god, what's Carmack doing? And there wasn't quite the same degree of transparency like of the internet, right? And so we got it wrong. We heard on the grapevine that it was like doing a divide every 8 pixels, which it was. And he actually used this trick, which is similar to the ALU thing earlier, where he's like, oh, you can kick off a divide on the floating point unit of a Pentium, and then while that's running, you can then use integer arithmetic to linearly interpolate the next 8 pixels, and then the divide comes back and you schedule it and everything's beautiful. But we didn't quite grok that. We heard like that it's 8 something, but we didn't know what the something was. But it exists, and there's a screenshot in this print magazine that I'm like, that's like 1 inch by 1 inch low, and I'm like staring at it going, it looks amazing. Like, so we built a whole polyfiller based on a completely different technology that was invented because we misunderstood Quake. Nice. And it was called, we called it pin mapping. Or Glenn Corpus, who's the genius at Bullfrog behind Magic Carpet's engine and various others, it came up with this idea of pin mapping, where we just compute the divides every 8 by 8 cells, like character cells on an old 8-bit micro, and then you just kind of compute what you do expensive divide every 64 pixels, not every 8. We didn't have any of the fancy scheduling, and then you just your fundamental loop is filling in a little 8 by 8 block with whatever UV coordinates you like. So you can do like bendy effects, and you can do, because basically you compute like accurate UV coordinates for each 8 by 8 thing, and then you fill in a very, very badly done but very rapid thing. So Alex go write the 8 by 8 thing, and someone else can go and write the divides for the rest of the triangle. And you have to crop it to the edge of, it's not 8 by 8. You have to like whatever. But the point was, it's Anton's point. Like, we completely misunderstood how Quake worked, and so we invented a new thing. It was definitely good. It wasn't as good as Quake, but it was fun, and we shipped a bunch of fun code like that. And
so, how do we know, Alex? Do we have this is a burning question in my mind. How do you know when to do the back of the envelope to prove to yourself that's something, and when do you not do it so that you can like kick off another side project?
I think you develop a gut of like what should be possible, and I normally go to back of the envelope if I don't know. So it's almost like filling in for your gut. Like if your gut can tell you, like, I know roughly how fast the laptop is. Like recently, as I said, for this hobby, I'm writing some C code again, which I haven't been doing for a while on a laptop. And I was like, I don't actually know how fast my laptop is. Like I've been using it for the web browser and like SSHing into like big GPU boxes for a while, but I don't even know how fast the GPU is on my MacBook. I don't have. Whereas for PS4, I had like a really tuned gut. Like I knew exactly. So I didn't have to do all of those kind of line side things. And then the time when you want ignorance, I think, is when you're like, I'd say it's more like open-mindedness of like, I don't know how I'm going to solve this problem, so there's no point doing back of the envelope because I don't even know what algorithm I'm kind of mentally. But as soon as I start to see forming in my mind, like, oh, I'm going to do mega texture and I'm going to do 64 by 64 tiles and I'm going to start streaming to disk. It's like, oh, okay, rubber's hitting road here. How fast is the disk? How long is it going to take to deliver the 64 by 64 tiles? So as soon as you have something quantifiable, you can go off and do the thing. But while you're still in like designer land, enjoy the lack of quantifiability and like
when you
Exactly.
when you start a project, like when you start a huge game, can you like assess what will be the performance heavy parts and then run the calculation for that?
You know what's hard for your team. So like the hardest thing in game making is what I call fog of war, which is that you don't really know what the game's going to be. I get really irritated by the whole discourse around like blah 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 lied. Like the famous one is like No Man's Sky. You know, like, oh, he said all these things and then it wasn't that at launch. And at the time he said those things, he was in the middle of making it. I don't have any insider knowledge, but like I know Sean, and I know that he wouldn't have been lying per se. He had a mental model of where he's going through the fog. He doesn't quite know how it's going to land, and in the end, it didn't land as he wanted. And then there's this glorious story. The reason I choose that as an example is because then the story has an extremely happy ending, and it goes and way exceeds whatever they originally said. But the point is that the hardest thing when you start a new game is what's going to be hard for the team. It's not so much a hardware thing of like, what is hard about this game design? Although I remember the Criterion over the road who made the Burnout series, Alex Fry was the lead engine guy on that. He's like, do you know what the number one feature of Burnout is? And I was like, what? He goes, 60 FPS. So, but that's really useful. Like, he's like, I will not concede ever 60 FPS. Like, this will be a 60 FPS game, and every decision we make from now on, every art decision, and it trickles into like everything, like how big is the world, how fast can you drive, like what is the acceleration rate, how many cars can you see, like how big is the UI, like really insanely everywhere. It's like, well, if it can't fit in the budget, you do something else, you change the design, and you let that constraint. So he chose that for UGC. It was like for Little Big Planet, it was like we're on a new platform with a new team making a UGC game where we don't even know it's called UGC because that wasn't a term that had been coined yet. We unironically pitched MySpace as a reference point for Little Big Planet, right? Fun. So we you don't know. So that the fog of war is the hard thing, and so you pick out what you think might be a path through the fog that might suit the strengths of your team. Okay. And it's the humans that you have, and you can't do everything. I can't go and make Fortnite because I don't know anything about Fortnite type games, but I know with the crew that I have at Media Molecule, or Anton's coming from America, oh my god, this is a godsend. Dreams is going to be better in these axes, in these Anton shaped axes, because now we have a human who can like push the envelope. And then like so this is more like a management thing, but like game development is a team sport, and it's like, what is the team good at, and like how can you differentiate yourself? And that's way harder than any of this technical stuff. Like technical stuff is almost like the joyous part of like you're sitting with your machine and you have a number you can finally measure, which is the speed of your SSD, and like that's actually really fun. But yeah, the hard part of a new project is like, what are we going to do that plays to our strengths and doesn't like not play to our strengths? Like,
regarding Little Big Planet, and then Little Big Planet 2, and then Dreams. If you were to compare the architectures, because like Dreams had this, I would say, wacky architecture with the G, all of the serialized state and fully deterministic, while being sort of MTD component system still. How did it look like for Little Big Planet?
It was non-functional, so it didn't have any of the functional stuff. It was much more traditional ECS. So it was things and parts, and we didn't quite know so much about cache, treating the cache well, but we had the notion of a flat list of physics parts, and so it was a much more classic ECS. And for LBP, pioneered some things that we carried forward into Dream. So I taught myself about servers and immutable content. So basically, everything in LBP was a content addressable asset, and we decided to dog food at the beginning. So one of the tricks I love is like, actually, there's a better answer to your question from before, like what's hard. So you look at what you're going to make, and we're going to make a user-generated content game. Okay, that means that the editor is going to have to be primary, like as part of the game. So we know that, and we know that we're going to have undo and redo. We know we're going to have save and load. And Dave did this amazing serialization system that was actually written up really well for the Handmade Network in the old days. There's a blog post somewhere on Archive about it. That's the Dave serialization system, or media molecule serialization system. So good. Power bang for buck is amazing. So we knew certain things that we would just go straight in for that you might avoid if you were just like, oh, I'm going to open up file, Unity, whatever. So we like go after this editor first thing. But the other aspect of it that was interesting to me was like, okay, all of the content might be user-generated. We don't even know what's developer and what's not developer. So like maybe we'll just assume that everything is likely to be user-generated. So our asset system, whether that's build, pipeline, blah, 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 will be leaning very heavily towards it can come from the server. And we had this discipline of like, can we make a version of Little Big Planet that is as small as possible? Ideally, it's just the executable. And I think we ended up with an executable and a font file, and it didn't need anything else. So you could boot the game, and it was able to treat every other file other than the font and the executable as if it was UGC. And so we dog-fooded the user-generated pipeline, and all of our in-house tools. And LBP wasn't pure. Like in the end, there was like developer assets and non-developer assets, and there was a lot of pain around that boundary. So it's not all roses, but we decided really early on that we're like, well, if we're going to go UGC, we need to like really, really try hard to use that system in anger, in a team of 10, 20 and growing to 30 people, really, really use it. And if it doesn't work well for us, then it's not going to scale to 1 million users on day one. So yeah, we had to go and build content addressable stores, and we made some mistakes as well. Like Little Big Planet did some dumb things around like tiny JSON file. LBP2 actually was the worst. Like it ended up doing lots and lots of round trips. So sometimes level loads would be dominated by just the ping time from you to the servers and back, because it would load something and discover it had to load 10 more things. So one of the things Dreams did was when you load a Dream, in a flat way it lists all the dependencies up front. So and it's actually, it's in the metadata, it's not even in the Dream. So before you even load a Dream, you know a perfect list of all the chunks. And then it uses there's a great algorithm called the rsync algorithm, which is about how if you have an opaque stream of infinite bytes of data, how do you chop it up in such a way that if you make modifications, you don't, like if you imagine a zip file and you change one character in your source before you compress it, every other byte in the zip file is going to change. And that would be terrible for a system where you're caching. So what you instead do is you have this system where you break it into blocks. But the problem is if you break it into 32k blocks, for example, then if you insert a character, then all the subsequent blocks are going to change. So the rsync algorithm is, at its core, is you randomly split the blocks, but it's not random. It's based on a rolling hash. So as you go through your long file, imagine you've got like Wikipedia or like a 1 billion byte file, and you're encoding it for the web, or sorry, to store on the servers, and you're rolling through, and you have this little hash that you compute, and it's like Bitcoin actually. Every time, I hate crypto, but like every time the hash has 4 zeros at the end, which has a 1 in 65,556 chance, we'll split there. Right, and then we'll put it. We'll just, no matter how big the block is, we'll cut there, and that's a block. And now we keep going. We read out a hash, and the next time it has 4 zeros at the end, hex zeros, we'll split there. The beautiful thing about this is the splits are content adaptive. So if I insert a byte, that block will get bigger, and maybe the next block the hash won't reset in quite the same way. But after the next reset, it will go. And I'm realizing now. So a while since I did this. I think we actually have a rolling window, so it's actually not an eternal hash, it's just like a hash of the last 32 bytes or something, so it's a short context window. So basically the context window will reset and you'll get the same exact chunk boundaries. So what Dreams ended up being was like, as opposed to Little Big Planet. Little Big Planet is this tree of dependencies, it's really slow. Dreams is like, no, we'll take all dependencies, we'll flatten them into a giant file, we'll then chunk them in this way, and then we'll list the chunks on the server before you even start. And that means when you go to a Dream, you get a list of all the chunks and you can download them. But we've bent over backwards to make the chunks maximally likely to be reused. So when you load a Dream, the server says you need these chunks. It's like, well, I worked on this yesterday. I had an earlier version of this game, and 70% of those chunks didn't change, and I still have them sitting in my in my drive. And because they're named by their hash, that's what content addressable means. I don't need to load them. And so basically Dreams, by construction, very carefully as a second system from Little Big Planet, minimizes round trips and maximizes reuse. And it's interesting that I think Sergey, like the founders of Google, their PhD was on exactly this. It was like deduplication and chunking, and it's a deeply fundamental idea that you want to build something efficient that to the user. And why do all this stuff? Is it because I have, I'm excited for some techie stuff? No, because I want the user experience to not suck. Like, I hated that Little Big Planet had long loading times. I loathed it with like every fibre in my body. So I was like, what can I do to maximize the chance that you get these chunks reused? And so like I liberally stole from rsync. So if you want to look up something more coherent than this rant, gzip rsyncable is a flag for gzip, and it's called the rsync algorithm. And maybe I haven't read the Google founders PhD, but apparently it's on the same topic. But
there's also rsync utility in terms of like at least Unix based operating systems.
To briefly describe that, if that's useful, like the reason it's called the rsync algorithm is because you have two computers that you believe have roughly the same stuff on them. Like you're syncing between two machines. And so conceptually I always had I have a PlayStation where you've been working on this level, you've played this level before, so I think you have most of what you need. But I want to sync with the server the latest version. And so the rsync algorithm is this genius idea that you can basically construct these hashes and very quickly communicate blocks and decide which blocks you have and don't have. So you very quickly have this like conversation with the server of like, server says you need these blocks with these hashes, and then you look locally and you're like, oh, I've got this one, but I don't have these ones. So you come back. So with only 2 round trips, you've completely agreed a schedule of what you need to do, and the server's like, okay, now I can efficiently go and fetch just those blocks and send them to you. But the twist in the story is, if you're syncing zipped files, everything is awful, because zip files, all the blocks change whenever you change 1 byte up at the front. So then you gzip with this rsyncable. So it's not just rsync, it's gzip -- rsyncable, which makes the zipped file amenable to this kind of deduplication process. So it's like building 2 halves of an algorithm, and then when they get together, you get this wonderful user experience that you're motivated in the end by, I want to sync my server and my client with gigabytes of data in the most efficient way possible, and designing for that is just such a rewarding experience, because it you feel it in the use of the game, like
Was it?
I care about this stuff too much. Sorry.
So minimizing round trips was like one of the things that you sort of like, or either discovered or like as a technique for this like user generated content / sandbox game. Are there any others? Like, is Dreams, for example, the architecture with the game state and like double buffering, like creating a state +1 from the frame, is it always better choice for the architecture for this type of games? Or are there like reasons not to?
I think Anton's probably better to answer that. Like he's done the follow-up in a way. Like I haven't. I made Dreams and I switched into a different industry. So I haven't but it was definitely had downsides. And one of the biggest, like the one-liner I would have is actually the cultural downside of like, it's really annoying to have to write code where everything works like a shader. Like I described deletion earlier, it was like, well, you just don't copy yourself into the future. And as someone who's spent his life writing vertex shaders and pixel shaders, the idea of like a self-contained unit where you're like, I'm processing a thing, I'm not allowed to talk to the outside world because it's, like I want to try as much as possible to sort of do everything as individual units, was natural to me. But it's not a natural way to write game code. And so I don't think it's likely that it's a good architecture for many things. I think it had great upsides, and it was an interesting learning experience. But I don't know, Anton, if you have thoughts on...
Well, I mean, so I think the reason it was like particularly good on Dreams is that, for one, it forced everybody to work at like a pretty flat performance speed, meaning that like if a user had that many entities, like the creator of the game would also get hit with like whatever performance is their worst performance, and that's like one of the. So for creators it was good, right? Because people that are not seasoned game developers, they don't always think about the worst case. So there's like those knock-ons.
I just want to clarify
what
Anton just said. Like, thinking about the worst case performance is way more important than thinking about the best or average. Best is never worth thinking about. Average is okay. That's useful to think about. But I used to joke that the Dreams architecture was uniformly slow. Like, Because if you think about it, you're having to recreate every, and it annoyed me. Like I went off on side quests that failed. Of like, how do I make it so that this 5,000 objects that haven't changed frame to frame, I'm paying this massive cost of reading every byte, deciding what to do, and then making a new copy. And it's like, it's slow. Like fundamentally, the Dreams architecture is way slower than a system where they would just carry forward from one frame to the next and only 4 bytes were changing. But I used to joke, it's like, well, it's uniformly slow. Because someone who makes a level where all of those objects are tumbling around or changing, or in the editor, the big one was editing cases where Anton you could literally zoom out the whole level, drag select the whole thing, and just start waving it around or editing it. And the point is, it degraded really gracefully, because the thing that we cared about was the worst case, not the best case. But that said, it was uniformly slow. It wasn't uniformly fast. It was like, but it was predictable. Sorry, Anton, I just wanted to plus one that point.
Well, no, I think I think that's a good. So I used that on Modeler a little bit to poke at the team, because once you do that, inevitably people are like, well, this is really wasteful. And I'm like, well, what's going to happen when you do it to 100,000 things or whatever? And they're like, well, then that's going to be slow. I'm like, why? But why is that slow? And they're like, well, that's like if the person should have a fast computer if they're going to do that. I'm like, well, that's when the speed of light calculation gets broken out. And I'm like, all right, let's look at this data. 100,000 things. It's like 20 or 30 megabytes of RAM based on what we're doing. Like, how fast can you touch that? And it works out. Like, I was just actually talking to people about this. So on Modeler for like circa 5 years ago, 100,000 things costs like 1 millisecond to touch and update like a flag. So if you just like raw loop through this thing, and this is like super vague and micro benchmarks are not real, but whatever. Like, it gives you a back of the napkin, because like, if you're a JavaScript person, you might say, well, it's going to take like a second or whatever, or 2 seconds. And you're just like, it's not true. So the reason is knowing the back of the napkin then lets you say, well, I'm happy to pay a millisecond to do this
all the time.
Like, if uniformly slow means 1 millisecond, that's great. Yeah. But then the price you pay is like, well, now we're programming in C, and now you're not using std vector, and you should like kind of be careful. And so when people say like, oh, I don't want to like prematurely optimize or all that stuff. So my view on that stuff is like, what I want to do is bank as much performance as I can up front, so then I can use it egregiously to solve the actually difficult problems of like, oh, I want to move 20,000 things. Well, instead of doing like dirty flags and figuring out what moved and doing all this like complex stuff that Alex talking about, it's like, well, you know what, if I just write it pretty well, I'll just like brute force it, and then I can move on with my day and like do something else interesting, right? Versus like, oh, I wrote it in this like pleasant language using hash maps, and then, well, for one, it doesn't work for 100,000 things until like some poor engineer has to optimize it, or I have to optimize it. Like, that is the more moral thing to do. So anyway, so that's like, I will mention where this starts to falter is battery life. Like on a PlayStation, you're like, whatever, we're running full tilt. But eventually somebody smart will come up and be like, well, you don't care about performance, but don't you care about battery life? And I'm like, well, yeah. And so then it starts to be a little bit more of a thing. But you can almost always put a cache on top without.
And here's the interesting thing, like people get this wrong all the time. So we're normally, I can relate this to something really well known, which is immediate mode GUIs, that old chestnut. And one of the criticisms of immediate mode GUIs is like, well, that's insane. You have to touch, you have to recreate every control. Excuse me, I've got hiccups. I'm so emotional.
That's close to heart.
So how could that possibly scale? You're going to touch every single, UI element every frame, and it's going to burn battery life. I've heard all these leveled against immediate mode GUIs. And the point is, initially the reaction is like, well, that's true, and that is a downside, but I get so many upsides that I'm willing to take that kind of in the pros and cons column. And you're not in denial that that's a downside, but I think the twist in that tale that I see over and over again is the simple thing, i.e. immediate mode, isn't as slow as you expect. Everyone is like, it's going to destroy your battery, and it's like, actually it doesn't. And oh my god, like I built a UI with 9 million panes and 15 widgets per square millimeter, and like it costs me 0.3 milliseconds, and like it's actually like insanely fast. And so people get the speed of light wrong, and then they do the complicated retained thing. And state management is the hardest thing in the world. Do not do state management if you can avoid it. And the beauty of immediate mode GUI is all the state management is Omar's problem, or whoever's problem. And you, as the user of that API, never has to think about state. Like he uses IMGUI, which, by the way, I don't know if people know, but like Omar's IMGUI, inspired by Casey and by Q Games, where he worked before Media Molecule, the version of IMGUI that is the immediate predecessor the famous DRM GUI, was a media molecule invention for our game Tearaway. And he created it, and then he said, can I open source it? And he rewrote it, and it evolved it a million miles from. No credit to Media Molecule there. But what I'm saying is I saw Omar in the Genesis days of the DRM GUI, right? And he uses it in such a wild way. So we had edit and continue at Media Molecule, as in we religiously made sure that worked, and we asked Sony to make sure the tooling worked. And so we could live edit C code and update it. And so as a result, there's a debugging thing you can do where you're debugging some complicated recursive nightmare. And so you literally sprinkle in IMGUI log or IMGUI button or IMGUI slider, and it will dynamically create. It's like instead of a printf, if your instinct is like, I'm going to put a log in here or printf, Omar will be like, no, I'm going to do an IMGUI slider here or an IMGUI widget. And live, he can see, like, for example, you'll see the structure of that algorithm running. So you're doing some fancy algorithm, and the structure of it is made visible just by adding one line of code. And then when he's done, he deletes the line and it goes and recompiles and it goes away. And so, and then my brain exploded when I saw that, because I was like, wow, you can use this as a way of, like, while the thing is alive and running, I can see, you know what that feeling you've got when you're looking at the code, and it's this weird cycle that comes from the 60s where you're like, I have to think about the logic of the code, and then I'm going to reason about it in my head about what the flow is, and then I'm like, is it going into this if statement? I'm not sure. And like Omar will be like, push me to the side, be like, insert IMGUI log while it's running, and ding, it appears in the thing. But more, the context is like, you want a call stack? Okay, well, we'll just put one at the front line of all of these functions and make an IMGUI node, or whatever it's called, indent one. And like all the state management is handled by IMGUI. And like now the call stack of my thing has just appeared, and then he deletes it because it's like, this is so cheap to make, and cheap to run. And you do it in places where it's outrageous that you should be doing this in the middle of, like an inner loop. It's like, I don't care. And it's like, and it works. And so battery life, I don't care. You can make it efficient afterwards. Brute force. There's one other example, which is Z. Did you know the story of depth buffers, Z buffers? It's like a footnote. So there's a survey paper in the early days of graphics where they were like, how the hell do we do hidden surface elimination? And clearly, like, we need to use span buffers and I don't know, potentially visible sets and all sorts of fancy algorithms. We need B trees. We need to like divide the world into convex cells, and we need to do all this stuff. And then there's like star, and then like in the footnote, it's like, of course you could have a per pixel depth, but that's a rubbish idea. I'm paraphrasing, but and that was where the Z buffer was invented. Like in the footnote of this survey, there was like, you could do this, but it's insane, it's stupid, and it's so slow in battery life. Right? And that is the dominant method of doing hidden surface removal, is the depth buffer. And it's coupled weirdly to, at that exact moment in time, RAM got fast, and that's where 3DFX appeared. Like 3DFX, to a first approximation, is amazing because they realized they could build this architecture around depth buffer. RAM was fast enough and cheap enough that they could stick everything. I don't know, I'm now out of my lane and getting it completely wrong, so I apologize to anyone who knows the history of 3DFX. But my understanding was it came at that moment when like the depth buffer with this brute force, this elegant, simple, dumb, so dumb it's dismissed in the footnote of the paper that invented it, algorithm wins. And IMGUI feels that way to me. And uniform slowness, but it's so dumb that it's really easy to work with. And then when battery life becomes a problem, it's surprisingly easy to modify a simple system. Whereas if you had like retain mode, fancy, blah, 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 you're like, well, I can't re-architect this now because it's like so much state, and state management is beyond human capability. And like, yeah.
So you touched on immediate mode GUI debugging, which I'm going to use to like pop the stack 16 entries and go to the thing you said. Well, I'm still curious about this, which is that you said, you're working on your home thing, and then you hit this problem where you're like, God, I want to be right back where I started in my state, right? And that's like a canonical live reload problem. And on Medium, like on Dreams, we had like the Dave serialization system, which meant you like annotate every field variable, and then you get this introspection like via macros kind of thing. But I'm basically like on the precipice of like writing my own C variant because I want that at the language level, right? Because the annotation sucks. Like I've used it on home project. Like it doesn't suck for Dreams because it's a big project and it's like worth it, right? But if I'm making like a little toy app and I'm like, oh God, I want to get the state and then I have to serialize the state. Really, I just want like all my states serialized, right? So I basically want live plus plus kind of functionality, but I want it also on reload of like the thing. So why don't we just solve that?
I don't think it's.
Small talk solved it, right?
Like, I mean, obviously, introspection is great. And
why is it not solved?
I think it's to do with vibe coding, not in the AI sense, but like you change.
What, in sense?
So
the real vibe coding.
So this is the thing of like you're
like demo scene.
You outsource bits of your project, right? As that spiel I had earlier. But there's also times, and I find this, the key thing that I've realized about myself is like I change over time within a project. So basically your cleanliness of code changes. So like sometimes you're in a mode where you're just like forward velocity is everything. I will just like write global variables and I do not care. And I will write like one of this thing. And it's related to Casey's compressive coding, is it called? Like, don't abstract something until you've done it twice, which I think is genius advice. But you can take that way, way, way further. I'm going to talk about the cosmos in a moment because I think this is really like underappreciated. But to get there, we talk about the negative case where I've messed up. So I want to talk about how I mess this up, and how I got into the place where I was having to restart and like click 3 times. And yes, we could solve it with serialization, but that wasn't the problem that actually needs solving. The problem was filthy Alex, right? So I got to that state because I vibe coded, meaning I just went into full in the zone flow mode, and there was global variables everywhere, and there was just mess, and I made a mess. And basically, even if I could serialize the state, it was scattered across a bunch of files. There was like, and it's not even global variables at the top anywhere in a nice list. It's like in the middle I have static space int whatever foo equals 7. If foo is 7, then do this. Like really YOLOing it because it's a hobby project. Like no, I'm not curing cancer. And so I was like, okay. And what I did was I stepped back and I cleaned for a day. And like that cleaning was paid for itself because now my 15-second restart time went to 0, and now it was trivial for me to serialize. As it happens, I just dumped the state into a JSON object because I had a small enough state that I didn't need a system to go. So what you're talking about is like step 2. Like I'm with you. We can all debate about like.
So yeah, so maybe your answer is there are 2 steps, because my kind of question is how can this be 1 step, and you're saying no, there are 2 steps. Don't get ahead of yourself, because I basically get in the same problem because like I try the counter example is I had like a medium molecule style serializer, and then I was like, okay, I'm gonna try to make this painless so that it's 1 step, and so I made like a macro thing where instead of having the serialization be like a sidecar thing, I just did it that every struct I declared was auto-serialized because I forced myself to like basically
but then
unify it. It was not awesome because it made me sad and I couldn't vibe anymore because
too much structure.
Every time I'm like, oh, I have to write this. I want to just write like struct open brace. I don't want to write add struct. And it's like there's a flow change, and then I threw it out because I'm like, this sucks.
Yeah, it's over-engineered or something.
Too much.
So I didn't choose to add serialization.
It can't be
seriously. I think what I'm trying to get at is the missing part isn't the serialization. The missing part is the organization. Or at least in my case. So like the magic of G.
Yeah. Well, I'm interested in how far can you push the disorganized filthy
No, you have
Alex,
to.
And can you even make it to the finish line, or do you think you have
toilet
to
cleaning
clean
has to happen, and it's worth it. It's like it always pays off. It always pays off.
Yeah.
And so that's why I want to talk about the Cosmos and Casey's compressive coding thing. So there's another aspect to compressive coding, which is when you feel the filth, right, and you have to make a gut call of like, do I want more filth here, or do I need to do the laundry? Or like, I'm stretching the analogy here, but at some point you decide, in this area of the code I have generated too much mess, I will now go and clean up. And and different people have different thresholds, but like you should listen to the Cosmos, right? And it actually applies to like, it applies to structure as well. So it's not just pure filth. Like I had something where I thought it was a good design. I didn't even think it was dirty. And what I mean by the Cosmos is I wanted to add a feature, and the feature should have been simple. So producer Alex, because as a hobby project I am my own producer, I was like, this will take a day of one evening, like in my limited coding time, and it didn't. It was like, and it was buggy, and I was getting bogged down, and of course it was state management. I had some multi-threaded issue between like audio thread and I was like, this is actually because it's a bad design. It's not even just filthy. I didn't think it was bad, but it's a bad design. The Cosmos is telling me through bugs and pain And also the code I was writing sucked. Like, when you write code, you're like, this just feels gross. Like, the classic sign that you need to look out for is, I'm having to reach through this pointer into the structure, and I can't, the thing I need isn't immediately obviously available to me in my context. Like, when you're writing code, you have some parameters coming in, you're having to reach across systems, you're like, oh, bad smell. Like, code smell is getting really whiffy. And that's compressive. For me, that's the same as compressive coding, of like, it is time to go and revisit these abstractions, and then and nearly always it's like a rotation by 90 degrees. So nearly always it's like, I had some indirections, but it was in the wrong way, or I had an array of structures instead of a structure of arrays, or an inversion of control of like, I thought that this thing was subservient to this thing, so I had a list of these inside this other one, but actually this is really painful, and what I want to do is pull that inner thing out to be global, or not global, but like at the same conceptual level as the other one, and then
accessible.
and so you start thinking in these terms of like, and I'm not clever enough to get it right first time, so that's why I call it compressive. So you sketch out an architecture, you try something, and then the Cosmos starts telling you this sucks because you're getting bugs, you're getting concurrency issues. It's like, okay, that means I'm doing my state wrong. What is wrong about my state? Why am I falling into these traps? I'm not completely stupid. And then you realize, okay, if I reorganize this, so it's cleaning, but it's also like re-architecting as you go, and it always pays off.
I think the reason I maybe run into this earlier is because if I'm doing UI for something, I want live reload always, even when I'm in the dirty mode, because what I'm doing is like tweaking constants and I'm adding stuff, so I can't like afford to have serialization be, well, or whatever method there is for live reload. Usually I just lean on Visual Studio Live Reload, but it's so buggy now that I feel like I just want to rewrite it. But like, I need to lean on it during the dirty stage, and so like serialization and state reset can't be contingent on the cleanliness. And so I'm with you that in terms of when you're starting to hit bugs.
Can we get concrete? Like, I don't know how much you want to share about this project, but like what? Because what I was going to say is like, in the end, most programs are really simple in terms of like, so the way I solved it without writing a serialization system was that I was aware that like the only state that mattered was basically what screen I was on, like what the state of the like game, the stuff that I already would want to save anyway. In my case, it was a text editor. I wasn't even building a game, but I was building a text editor, and I was like, it's stupid stuff like what tab is focused, like which files are loaded, and like the secondary stuff that isn't my primary state. It's not even like my main structures. It was these little globals, and so every time I booted the editor, it would always highlight the first tab. And there's always the fourth tab that I need to go and debug on. And so it's like, well, I'll just remember that now. And so I don't know what it is, but like, I didn't feel the need to make a system because the things that I needed to serialize were small enough. Like, it's a tab index. I'll put that in a JSON file.
You just went like bespokely, and you're like, I'm going to serialize the tab and the thing, and that's all I'm going to serialize. And the rest is like...
And then that was enough.
Yeah, I think when I was... This was coming from like a hobby game where it's like, oh, I've got like some spaceships and asteroids and bullets, and I want to tweak like the animation of the gun or whatever, and like, oh, but I hit this OpenGL state thing, so the thing crashed, and I have to like whatever, right? And so then I'm like, oh, I got to bring it back, and then it's not quite the same, and then so it was more just this like general desire, which is maybe like a faulty siren calling me into like the sea of live reload solving. But it was like this hope that I just get the state.
My gut says there that like you need to save the bullets. You need. I don't know whether you need a beautiful inspection system that is macro free or whatever, but you're going to need to dump everything.
You just save the game state.
You were right, Anton. You're just going to have to save that stuff.
Is it because you worked on Dreams? Now it's like every problem you see, it's like I need this array, I need this array, I need like everything in there, and I can always point to this array.
Well, yeah, you get spoiled because it feels like I should just be able to replay my thing. That should be a thing, but like it's not free, right?
You have to make some effort. You have to go.
Kind of. No. Yeah, and so what I was trying to square is this like I want to write dirty code, but I also want it to be saved because I want to prototype this thing. But
I've got another example. This one's wild. So Ragdoll Kung Fu. This is your ignorance thing earlier as well. So Mark Healy made this game called Ragdoll Kung Fu, and the story is that like he was making a sprite-based game, and actually he made a film with his friends in his garden. They all got really drunk, and it was really funny. It was like a stupid kung fu movie, like B-movie type thing with a camcorder, and before phones this was. And he decided to make a game of it because that's who Mark is. And he doesn't know memory allocation. He doesn't know pointers. He can write 6502 assembly. And his mental model is like 6502 assembly sort of thing. Like he's a C64 guy, and now he's an artist and a designer, but he can, he could code a bit. And someone had given him, maybe me, draw sprite at XY rotation, read mouse cursor and flip. That was the entire engine, and load texture from disk. So he built everything from those building blocks. And at some point I was like, I'll give you a Verlet physics. I'll give you a rope. I'll show you how to make a rope out of like a series of nodes, and then you draw things. And he looked at it and walked around this house for an hour. He's like, I'm going to make the whole game be ropes, and that's why it's called Ragdoll Kung Fu, because all the characters are basically Verlet physics. And he's one of these people who can take very primitive ideas like building blocks that he's been handed, draw sprite, read mouse, flip, and now Verlet integrate the position of a single bit of rope and turn that into an entire game. Anyway, so he now goes and runs and makes all of Ragdoll Kung Fu, and essentially I'm not involved at all apart from laughing because it's a hilarious game. And then Valve come on the scene and they're like, he presents at the GDC. At the John Blow invites him to the experimental gameplay workshop, and he presents this game he's made, and it's hilarious because there's no animation. Like you literally grab the limbs of this floppy character, and it's very, very silly. But he's extracted the juice from those building blocks. Anyway, so we go, right, well, we need to do multiplayer now. And so we're going to need to do save state. This is how I'm linking it back to the thing. We're going to need to save the state of the world. We're going to mid-game join. Like you're in the middle of a game, and we're just like, we're going to go all the way. We want to do mid-game join. And I was like, there's a feature in MSVC Linker that you can like put variables in sections, and you can name the sections, and it will sort them alphabetically. So I made a section called AAA, and it was like beginning of global variables. And then I made a section BBB, and I put all of Mark's code in it. And then I made a section ZZZ, and I put end of global variables. And the mid-game join of Ragdoll Kung Fu is grab the pointer of AAA, grab the pointer of ZZZ, zip the intervening bytes without any thought, just a single run of memory, zip it and send it over the wire, and on the receiving end, unzip it into the over the top of the running thing, and then like a couple of fix up, like you're still player 2 and you're still player 1. And the only reason that was possible was because Mark's code only had one idea in it, which is a thing. He didn't have it wasn't entity components, it was just like game objects. And he had one structure type in the entire code base that was a thing. And he even did like menu items were a thing, pots were a thing, characters were a thing. There was no distinction, and they just had loads of variable names. Like it was just like the mega object. I can't remember what it's. I think was it Ginger Bill's a big fan of this. Anyway, he did the mega object thing of just like all the variables, and performance didn't matter because it's just a stupid little 2D game. And as a result, there were only indices. Effectively, didn't know what a pointer was. So there were some links, like Verlet links, linked two things together. Well, it's just two integers, and I realised I looked at his code. And I audited every global variable by looking at the map file. Literally, I just went through every line, and I was like, that doesn't matter. That doesn't, like, all of these can just be serialized to memory. And so, what's my point? It was shocking how by only using very simple building blocks, it was like scalable to mid-game join on Steam. And the mistake I often make is I start building fancy stuff, and the fancy stuff always comes back to bite you because it's like you can't pull those kind of tricks. I've got another example which is Redis, but I won't go there. But yeah, so many good examples.
I think I'm on this wavelength because I'm not trying to make something fancy, but I'm wondering what is like the set of constraints. I mean, you're giving it to me here, which is like no pointers.
Also, maybe no versioning. But like if your thing is only live edit continue,
no versioning,
right? Then you don't care about versioning.
It's just a memory dump, just straight memory dump. Yeah. So the recipe is, I think, and this is consistent with how the project is already. It's like just one thing struct, array of things struct, indices only, memory dump,
disk done.
That's it.
And to give you an idea of how far that scales, Redis, the well-known, it's the key value store ++ data structure store, the original version of Redis, the way that it works is he basically stores everything inside a giant pre-allocated block of RAM. Like he pre-allocates 3 terabytes and virtual memory, and then just all the data structures are relative to that thing. And the way that you save a snapshot in Redis was literally fork. So basically, it forks a new process, and then because of the way Linux works, you get a snapshot of your process. So the parent process can carry on running, serving requests and writing stuff. The child process has this like frozen in time copy, and he literally in this early version of Redis was fopen, like open file, dump entire state of the memory from 0 to 4 terabytes, close, 3 lines, quit child process. And that was the entire, I mean obviously it's no longer that case, but he designed the data structures in such a way that you could just blat this thing to disk. And you're like, well, why didn't he memory map it in the first place? And I believe it's so that you can get this atomic snapshot. Like you could imagine if you didn't care about atomicness, you could just memory map memory from the beginning, and then when you crash, you've got a snapshot sitting on the disk. But now you're at the mercy of like what got flushed, what pages were valid and stuff. So by having this extra twist, you do a fork and a write and a close, you've got this like clean slate snapshot of the state of the world. And while you're writing, which takes 20 seconds by the way, Linux is busy. Like if someone comes and writes one of the pages, so you're writing, you know, the account balance of Alex to disk in this child process, and then I come in and spend some money on the main process completely for free in the OS. It will make a copy of that page, update Alex's balance in the running parent, and the child one will still be read-only, perfectly. It's called copy and write page stuff. So beautiful. So when I saw that algorithm, I was reading the Redis source code of like the Redis 0.000, or the first one that was ever released, and I saw this trick. And again, it blew my mind because I was like, this is so simple. This is Ragdoll Kung Fu applied to internet scale service that's like blowing up right now. And I was like, what is this? It's like, so don't think these are toy ideas. Like, you know, these are like outrageously applicable.
I think they're like the best ideas because, like, you know, people talk about like architecture, and I was like always like Alan Kay's speech where he rants like, we don't know how to do architecture because like architecture comes from Arch, and then Arch is this like thing that lets you build larger structures, and we don't actually know. We're still piling rocks. We're like in the pyramid stage where like it looks like an arch, but actually
that's the one where
rocks.
it's like we shouldn't call ourselves engineers or scientists or architects. We're just cavemen. We're like the beginning of 2001 hitting a bone against a thing.
Yeah. But I think it's not quite so dire. I think these things are like the arches, because when and maybe it's counterintuitive because we think architecture is so piled up with like OOP and hierarchies and all these bad things, and architecture is a bit like of a dirty word with our astronaut, architect, and all this stuff. But like, I think of it as, okay, here's a thing you do, and it's a little bit painful. Like, okay, we're going to do this immutable game state on Dreams or whatever, and it's going to be const G, and it writes to G. And it's like, this is a bit of a pain to work with. I'd rather have like my C++y thing and IntelliSense would work. But it's like, okay, but actually what it lets you do is this solve a way harder problem of like, now you don't need unit tests, right? Like maybe TM star, but maybe that's a bit of a grandiose claim. But like this happened with undo as well. I don't remember how Dreams did undo, but on Modeler we basically copy on writed like everything.
I wish we had.
And so
we weren't that
literally
arrogant.
is just copy the entire memory. So like the undo thing is like take all the state, copy it. It's like it's the dumb undo that people do. Like people say, well, the easy way to do undo is you just copy everything and then you just restore it when you're done undoing, and then you just don't copy the things you don't care about. And they're like, well, but that's too much memory, so let's like do this command pattern of like you do it or you undo it. And but it's like if everything's copy on write, well, actually the dumb thing just works, right?
That's where those
But of course, copy on write's hard to write.
That's why like those data
But
structures,
it's like that's
those functional data structures that are like,
Yeah.
I've forgotten his name. There's an amazing guy. I think he worked for HP, and he was pioneering. I've forgotten the algorithms, but there was treeps and various like. But basically, he was. Closure. There's a bunch of really great talks by Rich Hickey about closure.
Rich Hickey.
I just drink all of Rich Hickey's talks into your brain, because like those data structures that are around like are the embodiment of copy on write. It's like basically lazy copying, functional like understanding which bits can be split, and those are such powerful building blocks, and we don't use them enough in the games industry. But I think this point about like Alan Kay's, to pop the sack to that one, like you can still have taste. Like I don't mind architecture astronauts because it's just like what your taste is, and different people have different tastes, and there's room in the world for like different takes on the taste. But I like that it's worth having that taste. Like it's having the time to be like, again, the toilet cleaning example of like, this is going against my taste. I have made a mess for myself. And I am feeling worse. My velocity's gone down, my bug rate's gone up, whatever it is, and it's like it's a violation of my principles. All my principles are wrong. Like you go and reassess, right? You walk around the park 3 times, and you're like, I just made some poor choices, and that's how you improve. And then you update your taste, and you go again. And it's the taking on faith blindly that your past self was amazing, or that OOP will save me, or even just like entity component will save me. It's like, no, don't take anything on blind faith. Don't outsource your hard problem. So if your hard problem is physics, don't outsource it. If your hard problem is undo, redo, editor, build an editor first. So if I had a one-liner, I was like, if you can dare to build an editor for your game first, and you will set yourself up. It's pain early. This path is the pain early rather than the pain late.
Your game.
So your velocity will be lower. So maybe it's a choice. You have to decide whether you will make it or not. But like
on this point,
worth it.
When you say like build editor first, you kind of need to
eat
know.
A nugget.
Nice. You kind of need to know what the game will be, right? Like you need to have the.
No.
Not at all. Not at all. You just like.
And engine programmers all day.
Exactly. It's like you're gonna spend a lot of time like, oh, let's do undo on like how the state will be managed. It's like you kind of don't know.
No, because if your system is simple enough, you can change it. I mean, I'm preaching the idea that you let the cosmos tell you you've made a bad decision, you go back and change it. So you know what you think is going to be important to your game or hard about your game, and then you tackle that first, and then you really hammer it. So like I say, I'm doing redo first and serialization first, because I want or determinism, because I knew in my bones I wanted a good development experience. I wanted like rapid restarts, I wanted live reload, and I wanted these things, and they were my primary. They were like Burnout wants to be 60 FPS. Well, Alex wants an editor that's like rock solid and always works, and you can always, because the majority of your cost of your game is artists and designers making the levels. So your editor is like your primary lever for good or bad development experience, and the quality of your game of like what you don't know what the game is in advance. So I'm not angry with you. I'm just like, I feel very passionately that like most people making a game don't know what the game's going to be. But in order to discover what the game is, you need to be able to iterate really fast. That is the number one MSB. Nothing else matters. Iteration count is the only number that matters in game development. Like I have tried this 500 times and I have finally found the golden thing. Like very few people get it on the first or second or third try. So if it takes you 20 minutes every time, you will never make it to the 500th golden thing. So you don't know, but you do know that for me, iteration time is everything, and so that's what I'll do. And then I will go back and revise my decisions every time that starts failing. It also helps to hire good people. Like the Media Molecule team was really brilliant. There's a guy called Luke Petrie who is no longer in the games industry, but he was at Insomniac on launch titles for PlayStation 3. And after Little Big Planet was announced, he applied to Media Molecule. And I was like, hell yeah. Like, oh my God, how many people in the world have shipped a PS3 game at this point? Anyway, he came, and his attitude was amazing. His attitude was, I am here to make your development experience better. Like, I am going to stop at nothing. Like, wherever there is pain inside the studio, I will make it better. So, for example, he was the person when the game takes more than 5 seconds to boot, he gets angry and profiles the entire boot sequence of the game years into the project. So it's not simple at this point. It's not a trivial thing, and he like goes and parallelizes and threads and like makes everything happen in parallel and like profiles and measures, and just the game boots fast again now. And it's like no one asked him to do that, but he just was like, I will make this so. And my point is, he didn't know how to do that ahead of time. He didn't know what the destination was, but he valued iteration count above all else, and like for me that was the number one thing. For Burnout, it's like 60 FPS above all else. You know, that you might choose different things that you know ahead of time and that are like axioms of your game, and then you never ever change them, but everything else is fluid, right? Around those axioms you can change, rewrite all the code is cheap, just rewrite all the code if you need to. I think.
So what we're establishing now is that if you're making a complex project, you want to start with an editor, and then you want to have things like undo, redo, serialized state. Yeah. Put everything into like one type of thing, like a mega struct, fat struct.
That's one way to. So now we've phase transition. That's a way to achieve that. So the first part of what you said is true. Those are the goals. Then we segued into one way to achieve that very simply is to have a very simplistic data structure, a very simple way of.
If you have no idea what you're doing and you're just going to have like some things on some screen, maybe 2D, 3D, maybe textual, like you still will probably have a fat struct array of things and then serialize them. Like that's the bare bones of probably
a counterexample. The reason I would choose those choices, make an editor, serialize first, blah blah blah, was because I'd perceived low velocity game artist teams. So I saw myself as someone who's making tools for ultimately the entire audience, because it's UGC, but I'm making tools for the people around me. And if I see them suffering, so my most priority things are only those because they are the people I'm serving. It could be, for example, that you're building a game where you have a great editor already off the shelf from somewhere else, whether it's Unity, Unreal, or maybe it's like you've figured out how to use Blender or a text editor or some other way, and actually your artists, or your artist half of yourself, if you're solo, is already productive, in which case you don't need your priority to be make myself productive, because you already are. So maybe that in that case, you know, you've got a pipeline from a previous game, you're doing FIFA 900 and FIFA 899 has got really great tools, and it's like there's no need to change any of that. I don't know, the circumstances will be different. But for me, making LBP from scratch, making Dreams from scratch, my top bit was like, an interesting counterexample was I went and saw the Loco Roca. Do you know there's a game on, was it PS Vita or PSP?
PSP,
original PSP.
yeah. PSP.
And it was like Loco Roca, so you rolled this character and it had these beautiful curving levels where they were just amazingly designed, pixel perfect kind of curves, and you get the right velocity and you'd make it over the jump stuff. So I visited Japan Studio and I was like, how is this made? This is so cool. And their workflow was so awful, I almost died, and it proved me wrong in some sense. Like, it's possible to do this with the worst workflow. So they would do it in Adobe Illustrator, which is a great program, but the level design tool was Adobe Illustrator. And I was like, oh, that's cool, but you've got some quick way to get it into the PSP. It's like, no, I think it was 45 minutes from moving a Bezier handle to being able to experience, you know, the effect on the feel of the game.
Oh, wow.
And they just got good at it. Like, they were just, you know, they were surgeons of...
But that's the other thing.
I,
if you have, like, extremely bad tools, you need to develop this sense of, like, oh, how it's going to be there in the engine. Or there, like,
which is a useful skill, I guess. And I guess I use this example as like people have shipped brilliant games with awful tools. It is a thing,
yes.
But it doesn't excite me as a person with agency, able to make the tools better. I wouldn't stand for that.
Yeah.
Like that's not.
Another way of saying is like it's just too much of like a rock in your shoe. Like you have to remove the rock. You simply can't continue walking because like that's the kind of like I had this thing at Google where like the turnaround times for builds and stuff were like slow, and people worked with it, and it wasn't like clearly Google makes big great things, and when you're scaling and deploying to tens of thousands or millions of servers, like maybe that's just the way it is or whatever. But like I'm like you in the sense that I want to like hit the keystroke and see the pixels change, and if I don't and I know it can, I'm just like that. I'm rat holing on that problem now. Like just can't stop.
It's choose your battles, and like it's back to the thing of like what's going to differentiate your game or your project or your team or your own creation from everyone else's. And for me, it was always iteration that allows me to polish and polish and polish. I remember Siobhan saying to me, "Games are pieces of pop culture," and like it's such a stupidly simple thing. She's like, it's a perfectly created, you know, Coke can of like, doesn't matter whether you like Coke, Pepsi, whatever. Like it's this entity that you unleash into the world, and it's beautiful and perfect. And she's like, so you should care about it, and you should refine it, and you should polish it, and you should make it beautiful and as good as it can be. And for me, the way that I interpret that is like, okay, well, I make the tools that I'm going to use to make this perfect, beautiful, shiny thing need to be as good as they can possibly be. But there are other approaches and there are other, you know, priorities. But I love this idea that you pick the hard ones and then you really, really, really rinse the hell out of whatever it is. You push really hard. You do your speed of like, can I do this? How hard can I push this? And then I'll try pushing it. And I wish I could tell younger Alex to push things a bit harder, because I'd be like, I was working, you know, show off, showboat, ego, fulfill the dopamine, and then just like, it collapses if I double the number of entities.
I think it's really hard to do it. I'm actually curious, since you're doing hobby projects too now, I feel like that same mentality is really hard to do solo, because it takes so much brain power and capacity to do the tool side of it that I find it like pretty challenging to then do the actual usage of the tool of it.
Yes. So
like,
this
on Dreams it was easy because I'm like, I'm just a
I call this laziness
of
driven development. And I don't know why, but this has served me really well. So I am a really lazy person, like selfish, egotistical, lazy. No, I am lazy. And so I swear I do this inside my head. It's like the other day I've got two. Hang on, let me just think. I've got an example from Nvidia research, which we haven't talked about, and I've got an example from making audio software. So which one shall I go for?
If we can talk about Nvidia research also online,
okay,
like,
it's fine. Yeah, it's not a secret thing.
Let's but briefly like introduce the subject also, right? before.
Yes. Okay. So this is like this became the end of this thing is neural graphics primitives, which is a paper from when I was at Nvidia with a very brilliant Swiss German, he's German but he lives in Switzerland, guy called Thomas Müller and Christoph Schied and Alex Keller. So it wasn't just me; it's a group of us made this paper, and we invented this data structure called multi-resolution hash grids. Now, at the time, NERF, which was this neural reconstruction field, a paper from Google, is a way of basically taking a bunch of photos and then doing sort of photogrammetry type thing with a neural flavor twist, sprinkle it in 2021, and you get a 3D thing out. And that was very trendy. It was like hyper trendy. Now, we weren't actually trying to make a NERF thing. Appendix C was like, by the way, you can use this data structure to make a NERF that's like 1,000 times faster than any existing NERF at the time. And
Flex.
so, of course, that was the thing that
flex.
it's like flex, total flex. But we were like, we're not a NERF paper, we're a data structure paper. So we'll stick that in like, possible uses of data structure, like star, Z buffer might work.
Exactly.
We could, and then everyone knew it as instant NERF. I was like, oh gosh, let's try not to make a NERF paper. But sorry, that's to know what I'm talking about. So where did this project come from? And it came from extreme laziness. So there was at the time, and other people's ideas, like steal liberally and then apply laziness, and that seems to be a really good recipe, and I can't tell you scientifically why. So the recipe was this. There was a bunch of papers where they would take like NERF, where they would take an MLP, which is a multi-layer perceptron, so a very simple neural network, and you show it things and you train it through backpropagation to give you the answer. And people were using these things called coordinate networks. So you literally feed it an XYZ coordinate, or you can think of it like a texture. You feed it an XY coordinate, and this network has to spit out the colour. It's really easy to train because you pick a random pixel in your texture of, your beautiful picture of Pikachu or whatever, and little Einstein I think we used, and you say at 3.3,7 the colour should be red. And at 9,11, and this poor little network is just a bunch of matrix multiplies. It has to learn to perfectly reproduce that texture. And it does it, and NERF was basically, let's do this in 3D. So like, for a given ray through the scene, I've got a photo of it, and I know that should be red for that ray. And like, that's all NERF is. It's like, I will show you what colour this ray is, I will ask a network, what colour is this point in space? It's red. What's the alpha value? It's literally like, learn a volume texture. So I understood this as a graphics guy coming into neural land. I didn't really understand neural stuff, but I'm like, I understand volume textures, and you're basically getting this little tiny bag of matrix multipliers to learn a volume texture. That's like brutal. That's mean. That's like horrible. Meanwhile, a very brilliant guy called Tsuaki Takikawa, who was doing his PhD at the time, and I was helping to supervise him. He's doing this paper where he basically was like, well, do you know what? We should have an octree. And I was like, I know octrees. I know Unix. I know this is a Unix system. I know octrees. It's like, I'll have an octree, and then each point in the octree, I'll store a number that I can hand to the network as a little help. It's like a scratch pad. So no longer is it just alone with its matrices. I can now say, at these coordinates, what is the colour? Or by the way, to help you out, I looked up at those coordinates in the octree, this number. You can use this number as you wish. And if you want to change the number, that's fine. Backpropagate some new number into it. I'll initialize them randomly. Like, I'll give you random numbers in this octree and like use them however you like. So the network learns to train its weights, and it learns to update these features that they're called in an octree. Okay, so I was like, Thomas, nice to meet you, on Slack. Literally, I have this as my first message in Slack, and I screenshotted it. It's like, hi Thomas, nice to meet you. I saw that you did a paper where you used an MLP, this little network thing, to do radiance caching. So radiance caching is when you're doing a path tracer, and you trace a ray, and you land somewhere on my glasses, and you're like, I want to know what colour this should be, but I can't be bothered to trace any more rays because I've run out of time. So what colour is it? So you ask a radiance cache, and radiance cache is blue, dude. It's all good. So he made a radiance cache where he did this paper at SIGGRAPH where it was like, I will make an MLP to learn the radiance cache, and I will 10% of rays will go and do the work and find out that it's blue, and then we'll use that as training online, and they'll say, right, little network, next time anyone asks you, it's blue. It's like, okay. And then 90% of the rays don't trace the ray, they just say, right, what's the colour? It's like blue, dude. But this poor little MLP is like got 5,000 numbers in it, right? So you literally got. So here's my speed of light calculation. I was like, there are 5,000 numbers in this little black box. So no matter how good it is and how well trained it is, it's basically the same as a 200 by 200 texture. Like whatever 5,000 square root of is. I can't do maths, but it's about the same amount of information as a little texture. So you're expecting the radiance cache for this big 3D world to fit in 2,000 numbers. You're in 5,000 numbers. You're insane. So I say, hey Thomas, nice to meet you. Saw your paper, love it, good stuff. Also, I saw Tsuaki's paper, Octree, shoving features into like maybe to help out, maybe we could give a radiance cache with a lock tree. He's like, yeah, sounds cool. I'm actually working on it already. So, okay, cool, we're good. I was like, but octrees are really annoying. They're just so annoying to make. How about we just shove it in a hash table? And I'd come from Dreams, and we'd use hash tables all over the place. And like Simon Brown, a very brilliant engine programmer at Media Molecule, had gone and replaced a bunch of my octrees with hash tables, and everything had got simpler and better. So I was like, hash map plus MLP. So we try it, and it doesn't work. It's like, it sucks. And the hash collisions mess it up, and it's like, and then we're like, like graphics person, what do you do when something doesn't work? You add multi-resolution. So we're like, right, we'll do a bunch of hash tables, and it worked. And it was like magic. And it was born from the laziness of not wanting to do...
This last bit. Yeah. Can you repeat that?
Yeah.
It didn't work.
Okay, I'll come back to the algorithm in a minute. But the high level point I wanted to make was, we then went on a 6-month journey, worked very hard, made a paper. It was really good, and I can describe the algorithm if it's interesting in a moment. But the key point was, it was born from other people's ideas, 2 good ideas that I saw. That I was like, I will merge these together, and now I can't be bothered to implement them. They're too hard and annoying. I cannot be bothered to type in an octree plus an MLP. It's going to melt my brain. I've never done this before. I'm new to Nvidia. I've been here a week. I don't know. Help. And I know the hash table is easy to write in an octree, so I'll do it with the hash table. And then Thomas actually did it. But like, and then it worked, and we worked for a long time, and we refined it and stuff. And the algorithm is interesting in itself, and you can go and read the paper. But very briefly, it's just the same idea. You're handing this little network a little helping piece of information, but the trick is you hand it the hash table entry from a bunch of different resolutions. So you can imagine, I'm going to go there. Okay, let's go there. Like, let's say we wanted to store the color of every point in the room that you can see behind me, and I could use a volume texture, but it would be gigabytes and gigabytes. And the annoying thing is I don't need to store anything in all of the empty space. So I could use an octree and start like voxelizing and all that stuff. It's like too complicated, too lazy-driven development. We'll just have a hash table, and we will say, at this coordinate, what is the colour blue? And by the way, this point also hashes to the exact same point. I don't care. So there will be a hash table collision. This one will be blue, this one will be black. I don't care. The MLP will get confused. It'll come out dark blue. It'll be a bit wrong. So it didn't work. But then what we do is we have a bunch of hash tables where the hash function is different for each one. So basically, this one is like, hash table 1 says it's blue, hash table 2 says it's black, hash table 3 says it's blue, and actually it's a bit more abstract than that because it's actually features for a network and you concatenate them and stuff. But conceptually, the hash collisions are randomized across the different levels, and so different points in space end up with different collisions. And so you end up with a data structure that's incredibly GPU friendly because there are no pointer walks, there's only hash table lookups, and there's no collision resolution, and the MLP learns to deal with it, and it all just works. And so a bunch of algorithms got really simple.
When you then have like four alternatives for a given point, right? Or you do and you average them, or you pick the most.
That's the wild thing. We actually we tried all of the above, but we ended up just concatenating them, which means you just list them all out, feed them to the network, and the network can figure it out. So the network gets. It's better to read the paper. And my point wasn't really so much about the multi-res hash grid algorithm, the point was more that it was born from a desire to simplify and not have to code something complicated and not have pointers. Because I knew that it was going to be on the GPU, and I knew I wanted it to be really fast. I knew I didn't want to go and write a very fast octree walker that was like cache coherent stuff. I knew I'd been through that with Dreams, and I'd watched Simon replace it with hash tables. So in a way, I'm telling the story because it's like I had this nugget of information from Simon's brilliance. I had Tawaki's octree features help, and I had Thomas's MLP radiance cache. And Thomas, as I said, did a lot of this work. He was the lead author, I was the second author. So I didn't invent this per se, but I'm telling the story as a way of like my laziness brought those ideas together, and it was a valuable thing. So laziness is good. I
understand what you're trying to convey about laziness. I guess I'm defining laziness a little bit different than you, because like laziness is not for me, I look up these 2 papers and now I need to implement it, and now instead of implementing it this way, I try to implement it easier. Like laziness, I would define it a bit different. Okay,
simplification maybe. It's a very powerful... it's really interesting, Dave Smith. I love stories. So I talked about Physics Engine a couple of times, and we worked on this project called The Room at Lionhead, which is it's an interesting project. And there are some videos that Mark Healy tweeted a couple of years ago that he really shouldn't have tweeted, but I don't think anyone cares anymore because it's an unreleased project.
It
was
looked
never
awesome.
released, and Lionhead was
and it was so creepy and spooky.
And it had loads of stuff. It had cube-based crafting, Minecraft style. Like, so many near misses. We totally failed to capitalize on this thing, and like we missed a bunch of good ideas. But it's cool. Go and look at the tweets that Mark did. And what's my point? Okay, so we were working on this thing, and I'd done an engine that was really, really good, but I don't do games. And I was like, I need a physics engine now. And I knew this guy called Dave Smith had joined. He was working on Fable 1. So the time scale is he's working on Fable was ending, I think. And he was like, his CV, he was a first-time undergrad. He just joined, first job. And his CV was a physics engine. I remember seeing his resume and like playing this demo of a car. And I was like, that guy knows physics. So I wrote to him and I said, hey, Dave, I'm Alex. I'd like to put physics in my thing, but I don't know much about physics engines. I know there's this thing called Math Engine, and there's this other thing called I can't remember what the other one. It was like that's how old this was. Like there was a couple of competing physics engines out there, and I was like, I don't know which one to choose, and I'm not very good at choosing libraries, and I feel a bit off about this all. And he didn't reply. I was like, oh, bastard, he's busy with Fable, right? So I was like, okay, whatever. So I started looking at Havoc or Math Engine or something, and started like playing around with it. And then he replied like a week later with a functioning physics engine that was reproducing one of the demos I mentioned about that Math Engine had. That was like more efficient, more stable, and stacked everything perfectly. And was just like, I was like, wow, he's just written. This is incredible. So I was like, let me look at the code. So he'd attached to the email the code, which was one CPP file. So I was like, okay, I'll look at this code, and I couldn't find the algorithm. I couldn't find it. There was like, where is the physics engine? And it's because he boiled it down and simplified it. My point of this whole story is, he is an expert at taking the essence. So this is his version of lazy. I'm trying to find a better definition of lazy that's not so self-deprecating. Dave is brilliant at distillation, and he distilled what I needed. I had a set of requirements for my physics engine, and he'd read my email, and then he'd gone off and written the most distilled physics engine ever that just solved exactly the thing I needed really, really well. And there was no unnecessary craft. There was so little code there, I couldn't believe it was a physics engine. And I read it like 5 times. It's like, oh my god, is that all there is to it? Like, what? And so it's like, right, toss.
Where's the rigid byte factor?
Yeah. So just right, throw away. Like his code was less than the boilerplate that I'd already started adding to integrate. I don't remember which library. And they're good libraries. They're not bad libraries. But I was like, I can reduce the number of lines of code, and I can just drop an entire dependency, and then I lobbied to have Dave after Fable finished, and he joined the project, and then we canned the project and made Media Molecule instead. So like, very happy story. But I mean, I love that distillation power, and I try and do it. So my story about Nvidia was me trying to do a Dave and try and do distillation, try to distill the idea to its most lazy form, so that I can code it out in a day and keep the momentum going.
Yeah. And I think one of the reasons that doesn't tend to jive with people is because if the distillation was like, if the concept changes, the distillation
that's
might
true.
No
it is
longer
brittle.
be valid.
That is a
Almost
downside.
Like, And so, but if you're the kind of person that says just rewrite everything, the code is cheap, then it's perfectly fine and it's perfectly okay. But if you come from a mentality of like, a corporation that's like trying very hard to keep all the code it ever wrote, and like lines of code are precious, then it's like, it's frowned upon, right? Because you're writing this brittle thing, and it's like, oh, it's great that you did it fast. So then I think that's partly why that doesn't happen more. But actually, I'm on your side with that thing. If it wasn't obvious,
this rewrite thing, I think it's easier to rewrite. The problem is it gives you dopamine hits that are bad. So the classic is you do a rewrite and the rewrite fails. And the reason everyone says don't ever do a rewrite, it will fail, is because nearly always you do second system syndrome and your rewrite is overcomplicated, and people rewrite to make more. They think it's cleaner, but actually they're just making new bugs, and they fix the old bugs, but actually now they're just making way more bugs. Rewriting is valid, I think, if you can distill away. If you can distill, so like if the rewrite involves you reducing the lines of code, fixing past bad decisions, deletion, compression, distillation, then I think rewrites pay off. But the other side of it, the reason that's good, there's actually an even better thing to do, which is the ship of Theseus thing of like, can you incrementally, while the aeroplane's in flight, while the ship is sailing, change all of the planks into a completely new ship in a way that no one ever noticed, and production is very happy because everyone's productive the whole time. And that is undoubtedly the best possible outcome. The issue is Ship of Theseus capable engineers are 10x less frequent than very good rewrite engineers, and the problem is they're 10x less than very bad rewrite people, which is why actually as a first order axiom is like, don't do rewrites, it's bad. But if you can do a rewrite with distillation, if you can do rewrite distillation, do it. And if you can find a Ship of Theseus engineer, then you are very lucky because you can now go and get that person.
That's much easier. That's much easier for the discussion with management. Like when you want to say, let's rewrite this from scratch. It's like, of course, everybody.
It's really hard. I can't do it. I can't do it. There was a person called Paul Holden, who is the only Ship of Theseus engineer I've ever met. He's just a genius. And
it's so funny that the guy on Modeler who is also Paul.
Oh, really?
Like that was this kind of guy. So maybe you have to look for
if
Paul.
you have a Paul,
bias your
then
resume on Paul.
Do it, and management will be happy. But they're very rare. Yeah. They're very, very rare. Because
very quiet, so you can't find them because
he rebuilt Tearaway while Tearaway was being developed. Like he just the whole thing. Just like I've no idea how he did it. It's good for him. Like I'm glad that he has that skill, and I'm glad for Tearaway that we're able to do that. But I don't have that skill. But I do have some of the distillation power. So I'm in the middle camp, and then there's the and then the other one is Soldier. I guess the zero camp is we can't rewrite because if we're too likely to do second system syndrome. We can't ship a thesis because we don't have a pool. So we'll just soldier on with pain. And I guess that's how Loco Roco got made. And there's still a happy outcome there, right? Like you still made Loco Roco.
Most software is happening this way. It's made this way.
Yeah, I'm not throwing stones at anyone. Like whatever works. Like people are like, have you tried Zig? Have you tried Rust? Have you tried Odin? And Zig is right up my street. I don't know Odin as well, but Zig is my jam, and it solves loads of problems I have. I love comp time as an idea. It solves loads of problems that I specifically know that I have, that I know that comp time will. So I love, but actually I'm so productive in C, so productive. I'm old that I know that I should be into Zig, and if I was younger I would be into Zig, but I'm really, really productive in C, and I know how to not blow my feet off, so I just do that. But what I'm trying to say is I'm happy to other people do other things, like rewrite, don't rewrite, whatever. Write in Rust if you really must, but
so there are some languages. There are some languages that are not fine.
Well, I don't know. I'm not going to throw any stones at anyone because I think it's whatever gets the job done. I think was it Carmack has a quote like that. He's something like, "Better the tools you know." I don't remember the quote, but it's so true. If you know you're productive in something, that's worth a lot. When you're doing this calculation, should I do this? Should I get a physics engine? Do I have a Dave? Do I have a Paul? Do I have the knowledge to what's the more important thing? You have to think about that because you only have finite resources. But
someone should do archetypes of programmers and give them names.
Yeah, I wish there were more. I wish there were more diverse names. It's always single syllable male names.
There's I remember reading this article about Magic the Gathering game designers, and when they make new cards, they have these archetypes of people, and some people just write the really powerful monsters. The card could be crappy, but they buy the card because it's got a cool monster and it's really powerful. And they're just bam, and they never win tournaments, but they love it and they buy lots of cards. And so that was their name for that was a Timmy. Because it's this young kid who just likes to be. So I think we need to have the equivalent, but for programmers, it's okay, you got this Ship of Theseus person where you can hand them this thing. It's going to take them 6 months. You're not going to hear from them, but then it'll just be done. It'll be done perfectly, and nobody will even notice. But then it's it's faster and more stable, and it's that's Paul. And then
I think in these archetypes, one interesting thing. I know it's unfashionable, and it's a bit naughty to go into politics and stuff. I'm going to dare to just have grant me 10 seconds. You can all tune out for a second. Okay. But I've noticed that if you can get archetypes which are unlike you, it's generally a good thing. So I've noticed that people with different backgrounds to me inspire me or force me to think about things a bit more differently, and it's actually that jolt makes me better. And so sometimes I do lament the monoculture of games. It's improved a bit since the early days, and so I lament. I actually feel that quite deeply, that more programmers of different backgrounds, and I'm not just talking about gender and ethnicity, but it's those things as well because of privilege. But I just think in general different approaches, and so that's why I'm not going to throw any stones at anyone, because actually talking to a Rust programmer and learning about safety and or like Haskell, like I've been going down a Haskell rabbit hole recently, and I have no interest in writing Haskell, but it's different from me. And so in the archetypes, I will have the Haskell programmer, and they will be alien to me. But wow, it's eye-opening. People who can think in higher terms. Like I was reading some JavaScript code that was written by someone who clearly knew Haskell very well. It was all like combinators and higher order functions everywhere, but it was JavaScript. But I could not parse it. Like it took me hours to like understand it. And I was like, wow, this is alien language to me, but I'm learning so much, and it hurt my brain. And I got to the end. I was building a DSL, and this was an implementation of a similar language. So I was reading this implementation of a similar language to the one I was trying to write. And it was so terse and so beautiful and so elegant and so incomprehensible to me. And I was like, wow, diversity of language and idea and way of thinking, literally way of thinking. Like that person, I know their brain is wired so differently from my brain. And I was like, thank God for that person. Because it's easy to get stuck in a kind of, mucking around in C and grabbing pointers to beginning.
I think Media Molecule did that pretty well. I mean, like on Dreams, part of like the no style code guidelines was like what allowed for people like that to really flex and be like, yeah, I'm gonna write this part in a totally bonkers way. And it wasn't quite like Haskell level, but I think you guys did a good job cultivating that and bringing people in.
It's always helpful, and it's like diversity of ways of thinking, which can come from a number of sources. But
I need to hear two stories, and then if we can fit in time,
wrap it up,
by the way, we can do a break and then come back, or if we want to close out, I think we like.
It'd be actually if we can YOLO it all, because I should probably do bedtime. Actually, I've got a text from my girlfriend.
It's like 30 minutes.
It's getting on to kiddie bedtime.
30 minutes is way off, or it's okay. Okay, so 30 minutes.
No, I think 20. But if we do a break, it'll be difficult. So if we can
we can YOLO
through, that would be amazing.
Of course, I don't need to pee at all. No, I'm actually don't need to.
No, I'm just excited. My nuggets have gone cold. It was a good nugget. So I won't traumatize you with the rest of the nuggets.
If you have nuggets, feel free to eat them.
They're my reward when we get to the end.
Media Molecule hiring, and when people like onboarding, how did they realize themselves in this not the most common of architectures, and also like low level, but still you give them a lot of room to do their own thing and style of programming, but they need to be kind of within this framework. Like, how did you look for engineers, hire engineers, interview engineers, and then onboard them?
So there's an answer to that which actually nothing to do with Dreams. I don't know how good a job we did, as not having experienced it from that perspective coming in. I don't know how good a job we did of onboarding people. It was a smallish team and a smallish code base. So there were some of the systemic problems of huge code bases weren't there, and it was relatively clean. And because of Unicorn, we've rewritten it, so it was relatively small, relatively distilled. It was hard, and one of the things was like, I think Media Molecule now is different. Every company goes through generations. I represent a slice of Media Molecule. Media Molecule is a living entity. It's grown, it's evolved, and the team is very different from the one now. And as far as I know, I don't follow very closely, but the code base has changed and evolved as well. And that's a good thing. Like, it's like you want your code base to reflect the set of values and of your current team. And so the version of Dreams that I describe is the version that like Liam and I birthed, and then Anton shaped, and then Bogdan, who's a very brilliant engineer as well from the audio side, and all these people came in and shaped it. But as the team changes, the code changes, and you want that. Like, never ever cling on to something because it's some fundamentally good idea. It's like let it evolve with the humans. So I can't answer specifically for the onboarding of Dreams. I don't think we necessarily did a great job either. So we were okay. But the hiring thing, I do have something to say. It was again completely accidental. So when we started Media Molecule at the very, very beginning, we made a programming test, which I know is very unfashionable and untrendy. And there were two halves of the programming test. One turned out to be useless, and the other turned out to be absolute gold. Okay, the useless part of the test was something like locked free linked lists. I think Anton probably had to do this test. It was like, how do you do?
I didn't have to do it.
You're too good. Through. Okay, well, he's a hero already. But like, we'll take the hero. But it was basically like, is a linked list loopy? Do you know that? It was stupid, and especially in the days of LLMs now, like it's just like boilerplate. Absolutely, there was no signal, as we would say in these modern times. There's no signal from that half the test. Completely useless. The half the test that was good was the following: you got a zip file that was Space Invaders, and it was a Visual Studio 2003 project. So by the time we ended Media Molecule, we never changed it. That was crucial. So like the founding of Media Molecule, we made this test, and it was one C file, and you had, I think it was derived from Ragdoll Kung Fu, you had like draw, flip, read, mouse. And it was an implementation of Space Invaders that didn't work, didn't compile, had a couple of compile errors. It was very short, 30 lines. It was written inscrutably. Like David written some hilarious lines that were just so badly written, had no structure, intentionally. And it came with this cover letter that was like, Johnny Leet has messed us up, has screwed us over. He's written this and left the company. We don't know what to do. We don't understand the code. It doesn't compile, and it doesn't even work. Like when you get it to compile, you can shoot, and the bullets just sail straight through the thing. And then there's like a Space Invader movement where it's quite cool. They go back and forth, and then one of them drops down and goes round. And he wrote that as like a little piece of line noise, shader toy, code golfed nightmare fuel. It was just like one little expression in line that made the whole movement of the Space Invader intentionally. Like, this is all absolutely trolling our future employees. So we made this thing, and it's like, your mission is, you have to tell us how long you spend on it. It's up to you. We realise you have a job and a life, so spend an hour minimum, but as long as you like, just tell us how long you spent, and fix it, make it compile, put in scoring, and then do something to show us what you're made of. Like, do something cool that's you, that's your vibe. And that's it. That's the whole test. And different people spend different amounts of time. But the cool thing is, we didn't change. So everyone could do it. Anyone who couldn't do it is immediately screened. Like, that's fine. Like, there's a screening element to this I didn't even think about. But like, the returns tests would come back. And because we never changed it in like 12 years, I got this library of different responses, and they are literally personality tests. Like, I can point at each person who did the test, and I'm like, oh my god, there's so much of you in it, Mary, or there's so much of you in it, Claire, there's so much of you in it, Johnny. Like, Luke, the guy who is the helper I told you about before, did he add network play? I think he made it multiplayer. I think he's like, and he wrote in his cover letter, like, I was learning, there was some multiplayer library that was like, come out that was open source. And he's like, I wanted to learn it, and this came along, and I was like, well, I've only got limited hobby time, so I'll just make multiplayer. Another guy made beautiful explosions. It looked really cool, and like the code was a mess. He didn't refactor any of the mess, right? So I knew that person, and that person was never going to refactor code ever. But he was always, and there was another one that made it feel so good. It was the most fun Space Invaders, and he was a gameplay programmer. And again, the code was a mess. And I read the code, I was like, what's this? I ran it, and I had the most fun. Like 20 minutes I was playing it, everyone was like, can I have a go? And so like, you have this personality test, so valuable, the best thing ever. And again, we stumbled on it completely. And failure mode, the saddest story, God. And this is maybe Media Molecule's prejudice. So this person sent it back, and it was called Space Invaders One Day. So I spent a whole day on it. I really caned it. It's really cool. I'm really proud of it. And he'd rewritten the whole thing. It was unrecognisable. The code was beautiful. And by the way, we did hire someone who just did refactoring. But this person refactored. It didn't compile. And I was like, okay, it's so beautiful. I'm going to put the effort in. So I made it work, and I hit run. And he hadn't, I think the scoring didn't work. It felt worse than the original. Like, lots of things had broken. There were new bugs. So we in the end, we rejected him very politely, and we're like, I appreciated the code. It looked very clean. I didn't read it in detail, but it didn't work, basically. So no. A week later, a new email arrived, and it was like, Space Invaders _7 days. And he's like, I haven't slept. I've been working for the past 7 days, non-stop. I took holiday from my job, and I've been really working on it. And I looked at the code, and it's like, it's now 50 source files spread across a deeply nested, very, very beautifully architected. Like, there's an engine folder, and there's like a DLL, and there's like multi-stage build pipeline, and he's added CMake, and he's and it doesn't compile. I can't make CMake work, so I spend like 2 hours getting this thing compiling. Okay, and it still doesn't work. Like, there's nothing in it that I can tell about him other than the fact that he can massively write huge amounts of amazing looking OOP code. And the bullets, I think, collide by now, but he still hasn't added high score, which was like, the minimum feature you had to add. And that was interesting, because some people did serialization and saved the high scores, other people didn't. Like, that's interesting, but like, he didn't even get high scores. Okay, so he's like, really sorry, please stop working on it. I love that you worked on it so hard, but we didn't ask for that, but it's great that you're learning and stuff, but still no. And here are the reasons, and like it didn't actually work. Story's not over. A month passes, and Space Invaders _1 month arrives,
Wow.
and he's written Unity. I mean, at that point, it was like
Wait, what?
hundreds
in
of
Unity?
it was. I mean, not really, but he had an editor. There was like. There was an entire entity component system, I think. I can't remember, but it was epic. There was like the zip file was like,
But
you
didn't
know,
compile.
100 megs of just source code. And still, it wasn't fun. I think it did by this point work. But, and he had like a cover letter where it's like, there's an editor and you can change the attack waves. But it all sucked. Everything about it sucked. And yeah, so I don't know, that's like a failure story, but it's interesting that the personality was the more important thing than the programming. And yeah, wow. I don't know what my point is there. It's just a story I had to tell.
I don't know what
about
where
hiring.
to go.
I mean, that seems very that is the oop that people rail against, right? Because you could have had all that and then it was fun to play, right? And then everyone was like, yeah,
exactly,
oop's
exactly.
great.
It's like, wow, you are an amazing
Like-
architect, better than me, and you can deliver on the
Right.
requirements of the actual thing to run and be
But
fun.
somehow it always tends like.
And
Yeah,
I think
anyway,
in the
I
right
won't say
team,
it.
right? I'm sure he went on to do great things and like architect something, but he was missing an ingredient that we needed. And so I'm not saying this story to say he was rubbish. I'm just saying his
I think
priorities were not what we needed. Yeah.
I wonder if when you say like you want diversity of mind, which I'm totally on board with you, I'm not sure you want that diversity of mind. Like there because like something there isn't like, because I don't know how to phrase it, but you want like, you know, like I watch Rich Hickey's lectures and I'm like, I want to learn from this person. I'm not going to write closure. I can barely understand what he's writing, but I can feel like the value, right? And I can feel this dude knows what he's talking about. But like, I could also imagine like the same kind of thing you just described, but like in closure. So it's not even like OOP specific.
Oh yeah.
But there's like this feeling of like mistaking the purpose or like the.
I think it comes down to what your
means of it for an
what your
end
joy
or whatever.
is, and I'm reminded of like I'm in a middle ground. So Casey again. Sorry, I'm going to quoting Casey a lot, but the dude does say some cool stuff. And he was talking about AI and LLMs, and like I can't remember the exact context that he's like, do I use AI? And he's like, well, there are a bunch of people who are, come from the Java school of my age. Who come, like they see programming as this annoying thing you have to do, and it's just a job you do, and you don't care about it. So those people will be replaced by LLMs because they are producing code that they don't care about and they don't enjoy the process of making it. And then in the middle ground, you have like. I don't actually enjoy coding that much, but I love the process of making a thing. Like, as in, crafting something and it appears on my screen. I still get that joy of like, wow, pixels are moving and I can push up WASD and I can walk forward. Like, oh, it's so good. I get joy out of that process. And so for me, it's the journey, not just the destination. So for the people who are only into the destination, sure, vibe coding all you like, and your job will disappear because you don't care about the job part. You just care about destination. It's like, fine, I'm not throwing stones at you. That's a set of people. In the middle, you have people who are like, I enjoy coding games and I will make cool things on GitHub and I will share stuff and it'll be cool. And it's not to get big or rich or whatever, but like I made a cool thing and like that's your motivation. And then at the other extreme, you have people who love coding for coding's sake, and they're also cool. And this person, I think, was someone who just loved architecture, loved building out structures and code structures and blah blah blah. And as it happened, Media Molecule didn't need that person, but he was at the extreme end of like. It's the journey, but it's not just the journey, man. It's like, how structured can I go? Like, how many layers of abstraction can I build?
But you say medium...
The journey. It's like a vagabond kind of vibe where you just journey, but
you're
you're not going
no
anywhere,
destination.
but you're just journeying.
It
Because
doesn't
you
run,
love
it
the
doesn't
journey.
pile,
Yeah.
it's not
Yeah.
fun. But wow, the architecture.
Media Molecule didn't need this person, but can you imagine a company that is trying to deliver something and needing this person? This is my fear with this kind of mentality architecting for the sake of architecting. And like often I'm from Europe, so often, especially Eastern Europe, have situations where you have like an IT company that has an office in America, in USA, and there's a team of architects in USA, but as people in Poland, we're supposed to deliver stuff what they architect. It's like it's the madness.
It's hard.
It's total madness.
Do you know what the most deep the deepest law, I think about this a lot, is Conway's law. Are you familiar with Conway's law? Do you know Conway's law? That is the thing. And what blows my mind about Conway's law, which I'll state for the audience in a moment, is it's written so bluntly. It's basically like something along. I'm going to get it wrong. Should I look it up on Wikipedia? It's something like an organization is doomed. Will. This is what's so absolute. It will produce software that is structured the same way as the team. So if you have low bandwidth communication or bad communication between a team in Poland and a team in America, without throwing stones at either half, your software will be in two halves with a janky API in mid, or it will fall apart along that axis. The example that I think was compilers. Like if you have two teams working on your compiler, you will get a two-pass compiler. Like fundamentally, there is no, and because communication of humans translates directly into the communication of the bits of the software, and I think about that all the time, and you start seeing it everywhere. And so, like any time you have these structures that are built organizationally, it really messes with the software, because you get these awful breakable and if you have brilliant API designers, so maybe this person could slot in as someone who enables that bridge that must exist because of Conway's law. Maybe he can make the bridge good. I can't. I'm bad at designing APIs, and I need to be able to get that Cosmos smell and go, so Alex built this, and future Alex built this, and oh my god, it's starting to break. And it's like Alex made a bad choice, and now I shall rewrite it. And that second step never happens in a kind of.
See, I think everyone, not only Alex needs the Cosmos, everyone needs the Cosmos who is programming. And this is like if somebody is solely architecting, it never contacts Cosmos. There is no connection.
Yeah, exactly.
And that's the.
And then I'm going to diss Nvidia. Sorry, Nvidia. I actually loved working there, and I think it's a great company. At least the research team was wonderful, and I love all my colleagues, and love you guys, and girls. But the thing that blows my mind is CUDA versus graphics versus optics. I was like, I originally thought optics was just CUDA. And then I was like, hang on a second, I can't trace rays from CUDA. I can't use the transistors that were lovingly made by the Finnish team from heaven, the incredible team. They made the ray tracing hardware, but I'm not allowed to call it from CUDA because I have to be in optics. But once I'm in optics, I get a slightly different compiler with a different set of bugs, and I can't run other people's CUDA code. And then the third way is like graphics. At the time, from graphics, if I want to talk to CUDA, I have to create special context, and I have to memcopy between them and have barriers. And I was like, oh my god, these are the same transistors on the same chip by the same company. But even without knowing anything about Nvidia, you can tell that the CUDA team, the optics team, and the what was the third one? Graphics team are in some way distributed in a Conway's law way that means that they're doomed to create this tripartite thing. And I don't know the details, and it is hard. It's a hard problem, and I'm being mean because I know that actually. There's good reasons for it, but
I'm kind of pondering what you're saying as you're saying, because if Conway's law seems to generate these structures and they're undesirable, what does it say about a person who generates these structures within their own single code repo? Does that mean that their brain is effectively Conwaying up, or there's bits and if we want to remove the Conwayness, ideally, by the sounds of it, clearly it seems like the opposite of the person you might want, just intuitively, because if that person's even in their solo pursuit, they're adding more Conwayness.
You basically need to increase the bandwidth to your other half, right? And so for me, the version of Conway that happens to me is time. I'm really bad at reading code. I have a low tolerance of reading my own code. So my Conway becomes past Alex talking to future Alex very badly. And so I'll see some code I wrote and I hate it because I don't remember why I did it that way. And so my version of Conway is that you get the newest thing works really well, and then the progressively older features kind of decay. And my sort of immune system response to that is always to rewrite. I can minimize that problem or that failure mode of me by slicing off the old stuff and deleting it and distilling it.
Which is why you can't do Shipathesius.
Yeah, that's why I can't do Shipathesius.
That's the same gene that prevents
so someone else with a different set of skills will have a different failure mode.
But I think your point is really valid, because I'm drawn to this idea that this person who is effectively like a drug addict of sort may also be like the best rehabilitation person for this problem. Like, because you put them in and you're like, we have a con waste problem. And they're like, I know the con waste problem. I've lived with the con waste problem on the streets. This is what I do in my personal time. And then you're like, can you fix it? Yes, I can fix it. Like, maybe you're right. Maybe that is the value. And you do want like one architecture astronaut just somewhere that,
as long as he feels the cosmos, to Lucas's point, like as long as that architect feels
the
it. Right. Sorry.
I still have like two questions. Okay.
I can't believe, I don't know if anyone's watching this, but like amazing if
There's
you've made it to
100
2 hours.
people watching right now, and also like people will watch this after the edit. So
oh my god.
But I can show you this graph. Like always, there's a graph on every YouTube video of like audience retention, and it always looks like pew.
Yeah, exponential.
So we'll see like
same with
at
game
the
sales.
end, like we'll see at the end, like what the most like hectic discussion happened, like who will remain.
Yeah.
I need a story from Fable development. I love this game. I exploited the economy in this game. You could buy every item and then sell it for the higher price because the market person didn't have it. So
I'm going to pause it. I'm
money.
really sorry. I didn't work on Fable, so I don't have that many good stories. I have adjacent stories. I was in the room when Fable was made, but I was on another project. So
really?
Yeah.
Okay. Okay.
Yeah, I'm really sorry.
So then the story from Black and White, which was the earlier game of the godlike management of the village.
I've got lots of stories. I've got a funny story about Easter eggs. It's full of Easter eggs in a way that you'd never ever do Easter eggs ever again. So we even got it localized. So basically, there's these characters, the good and evil spirits that come and talk to you. They're the narrators of the game. I actually coded, they were completely my baby. Sorry for anyone who hated them. Not my design, but that's all me. And so I was like, I knew how to get new dialogue added and new cutscenes and stuff because that was all my systems. And the QA people needed a way to quickly jump to the 5 levels, even in like ultra gold release, no debug mode. And they were like, please, Alex, can we have a cheat to like get in to the other levels? But because I was a young kid, I was like teenager at the time, I was like, I'm going to go all in on this and we're going to get it fully localized. So I made a little red UK phone box with a cloud over it. So if you did a secret gesture with your mouse on the first level, a little phone box would appear, completely anachronistic on purpose, with a little cloud raining because it's England. And if you go and click on the phone box, you get this full cutscene localized into all 20 languages by the voice actors. Where they're like, hey, don't tell the boss, but this is happening, and you go through the cutscene and play a little bit of game, and then basically 5 more phone boxes appear and they become teleports to the 5 levels of the main sequences of the game, so that the QA could skip the game. And
skip.
One day Peter Molyneux, Peter walks
like
into QA. And he's like, you've only had this build for 10 minutes. How are you on the final boss? Like, what? How is this possible? And then, we used to this kid, like QA tester, she used the phone boxes. He's like, the what? So we used the phone boxes. He's like, you didn't tell me about the phone boxes. So, oh god. So they removed it before it went gold. He's like, there's no way we'll ship with this. So when you click the phone box, at the end it says boss says no, without recorded dialogue. It just does text that says boss says no, and I had to remove one because I was like, he's like, you can't change the code with passcode lock. We're like 1 week from Gold Master. Like, what is the minimum change you can make that will disable this? And I'm like, well, if I rip the whole thing out, it might change some tables, and I'll change one if statement to be like boss says no. That's Easter egg 1. And Easter egg 2 was, and so many people wrote to me when I tweeted this. They're like, my childhood was so messed up and I thought I was mad, literally. So we recorded in every language. We got a list of the 50 or 100 most popular names in that language. So it's fully localized again. I'm very proud of this being like a international thing. So you take 100 most common common names in your language, and we got the voice actors to record really spooky, like Wookash, Anton, like this, right? Murder. And at midnight, if you played after midnight, I looked at your Windows login name, your game name, EA name, any name I could get my hands on through any API, and I did a very rough Soundex match, which is like an algorithm for comparing like loose matching. If it matched any of those at midnight, we would play your name.
way.
And people didn't realise the game knew their name, right? So they'd be like, I swear it said Alex Murder. But I just put it out of my mind. It's like, it's probably nothing. And that was
I remember that.
So that's my...
Like, I remember hearing, I don't know if it got my name, but I remember it saying stuff, and I was like,
what? Yeah, what the hell's going on? Yeah, that's my favourite black and white story.
Wild.
Now there is a bit of a genre of games that do this, like they mess up with the files in your system. You need to, like, during playing of the game, you need to look up a file to continue and progress. Like it is now a thing, but they kind of like are explicit with it. If you're like,
do they actually mess with your file? Like, they actually change
yes,
your...
they can, like,
oh my God,
they can remove files.
That feels like beyond the line for me. But okay, yeah, well,
maybe just read only. Sounds like
I don't mind psychological torture, but you're not allowed to touch
it's not
my
like removing,
files.
like, for example, you zip something, like attempt to zip archive a directory, and then like you need to unarchive it. You need to pass something. It's like, it's a bit messed up. But
terrifying. Yeah, no.
But actually,
okay, touche. I admit it's messed up, but that version of messed up's not my messed up.
How did you convince like 20 voice actors to do like localized version of a bit that you're not gonna tell about that game director? You're just gonna do it on your own, like ship.
Yeah, they don't know. So there's just like, for them it's a spreadsheet of 5,000 lines ago.
So just added the line.
And line 4,000 is Alex. So they're like, whispered Alex. So they go, Alex. I'll tell you one fun bug story as well, and then maybe I should wrap it up and say goodnight to my kids as well. But like, my favourite bug of all time was on Little Big Planet 1, I think. And again, we were very close to Masters, the old days when patching was hard, and soak tests started failing in Japan only, and we couldn't figure out why. PS3 was crashing, and it was only in certain builds, and so back and forth. The problem is it took 24 hours every round trip because time zones and testing and da-da-da. And so we have like 10 days, 10 of these round trips, and then we have to master it. And like, why is this crashing? Class A. Oh, by the way, Sony, I don't know if it's still the case, but at the time Sony had really, really rigorous, brutal TRC checks. So in other words, if your game crashes on soak test, they will not release it. You will slip the date, and publishing be damned, money be lost. Tough. And so we're like, we have to fix this bug. Like, Japan will send the bug and say crashes overnight, game will not ship. And so it's like pressure 0 X trillion, right? And we're like, what's the thing? They shipped the PS3 over to us, still doesn't repro on the same physical PS3, still doesn't repro in the UK, and we're trying everything, like what's going on. It's like, we have an iToy plugged in, we try it, we reproduce everything the same, and eventually it's like someone genius in Japan is like, it always crashes at 4 a.m. Like, okay, well, what happens at 4 a.m? And it was the cleaners, and the cleaners would come, and the Japanese cleaners were very thorough, so they would clean, I guess, for a long time, and the game would crash. So as soon as we hear this, we're like, okay, so we put on radios, and we turn up the radios. Sure enough, the game crashed, and it was a memory leak in a piece of code that took the compressed audio from the webcam that we didn't even know was running, because it wasn't meant to be running unless you're in a network game, but it turns out accidentally it was running benignly, or not benignly, and if the UDP packet for the compressed audio was bigger than the MTU of like 1500 bytes, it would split it into 2 UDP packets, and then by mistake we would leak the second UDP packet. So you had to have non-compressible audio for a long period of time, and then the game would leak and crash. And that is quite possibly the most gnarly bug I have ever... I didn't find it. I think Matt Willis credit.
So the white noise vacuum didn't
compress well enough.
Basically,
it was actually Sony's leak.
So it was not always around 4 a.m. because it wasn't like perfect 4 a.m. It was like around 4 a.m.
when the cleaners came. Yeah. It's a nightmare, but we found it, and Matt Willis found it, and
well, how did
it was
you
like a one line, it's like
how did you trace the steps from like it happens at 4 a.m. and then what? Like, how did you make the?
Well, we literally said what happens at 4 a.m. and they're like, don't know, cleaners, and we were like, we knew that iToy was required, we knew that their camera was required, which has a microphone. So the only two pieces of information we had was like microphone and noise, or like cleaners. So that was what unlocked it. Okay. It's like,
wow,
nightmare bug.
Well, that's a great bit to end on. Thank you so much for joining me, Alex.
I hope it was enjoyable. I hope everyone listening enjoyed something in that.
I think so. People in
apologies.
chat are saying that when you said a couple of minutes ago, it's like, I don't know whether anyone is still watching. It's like people are saying like, no, we're there, we're enjoying pretty much. So
okay, cool. I'm gonna go eat my nuggets. But thank you so much for inviting me on. It was fun.
Alex,
Thanks, Anton, for
enjoy
sparring.
nuggets. You can stay a little bit, Alex and Anton, because for the video to upload, and I will end the stream.
Okay.
Everybody, thank you so much for joining us, and have a good night. If you're on the same continent as me and Alex, if you're Anton, the same continent as Anton, start working already and have a fun day.
Thank you.